Inshallah, in this training course with the beginners level, we will discuss some important points regarding Autodesk Inventor features, how we can make a 2D sketch and convert this 2D sketch to a 3D model by using 3D features of Autodesk Inventor, and how we can make solid parts, sheet metal parts, assemblies, and prepare the fabrication drawings. In this today, inshallah, we will discuss, we will make an introduction about Autodesk Inventor and the capabilities of this software and how we can use it in our industry. Autodesk Inventor interface, we will discuss the interface of Autodesk Inventor and how we can show the toolbars and how we can deal with the toolbars. In the third point, we will discuss how to create a new project and how we can deal with the old project, how we can navigate inside the 3D world of Autodesk Inventor. After that, we will learn how to make 2D instances like lines, splines, circles, arcs, etc. After that, we will learn how to make a constraints for the 2D sketch, like adding dimensions, make a line perpendicular to another line or parallel to another line, all of that. The next step, we will learn how to make editing on the sketch, like moving some parts of a sketch or all sketch, copy some parts of a sketch, make a scaling or split on lines, make a rectangular pattern or circular pattern or mirror. After that, we will learn how to change the units of the file. If you would like to deal with the units in inches or centimeter or meter or millimeter, the weight, if you would like to deal with it in kilograms or pound, or so how you can change the units of your document. How to insert a photo to your sketch, and how you can import Excel file including allocation of points in X and Y and Z location, and how we can import an AutoCAD drawing. Finally, we will make some examples to understand or to catch all of those features in some samples, to understand how we can combine between 2D instances, editing of the 2D instances, how we can make a constraint, all of that. Let's ask, what is Autodesk Inventor software? Autodesk Inventor software is a CAD software, computer-aided design, developed by Autodesk company. This application, you can use it for 3D mechanical modeling and simulation, visualization, and documentation. This application is a parametric feature-based solid modeling, so it allows you to convert the 2D sketches to a solid or surfaces model. By using Autodesk Inventor, you can make a parametric relationship. You can make a direct editing from free-form modeling. And during, inshallah, the next slides, we will discuss that in detail, inshallah. Autodesk Inventor is a powerful application. You can use it in many different applications, like in oil and gas field, in mechanical field, in architecture field. So by using the capabilities of this application, you can make many different things. You can make a sheet metal frame, like steel structures, tube, cables, harness. You can make a design, layout, rendering, simulation, and more. Okay, in the next slides, we will take a tour on Autodesk Inventor to know what we can do by using Autodesk Inventor. The first thing, you can make solid parts. Like if you take a look on your front, you will find a keyboard, for example. So you can make a solid part like a keyboard or the mouse, glasses, anything. You can do it as a solid part by using the features of Autodesk Inventor. You can make sheet metal parts. Around us and in our industry, a lot of things created from sheet metal. In our industry, for example, the body of the storage tanks, the pressure vessels, towers, the heat exchangers, saddles, skirts, all of that created from a sheet metal. So easily by using those features of sheet metal, you can make blade development, and easily you can send that to as a scale 1:1 to your workshop drawing to prepare the cutting sheet for the sheet plate items. You can make simple after making the solid parts or sheet metal parts. You can generate a complicated assembly for an equipment based on the parts that you create. You can make a steel structure, simple steel structure, by using the frame generator tool. The frame generator tool, it's an included tool inside Autodesk Inventor Professional. So you can build a skeleton for the structure. After that, define the standard of each beam and the size of each beam based on the standard, like Indian standard, European standard. After that, select the section IBE 100 or UBN, all of that. So you build a skeleton, 3D skeleton. After that, you can use the frame generator tool to convert this skeleton to a frame from steel. By using the tube and pipe tool, you can make a piping, cables, harness assembly. So this tool gives you the ability to make, in our industry, if we discuss that in our industry, you can make a combination between the frame generator and the tube and the piping tool to make a sked, a complete sked. So the sked including a steel structure, and you have a piping above this steel structure, and you can make by using the sheet metal and solid parts, which we discussed on this slide. So by using the combination of those features, you can make a complete sked. You can prepare 3D drawings, which include bill of material for your mechanical part. You can make a presentation like that. Now, this presentation, you can make simply moving assembly for parts like here. For example, this is a heat exchanger, steam heat exchanger. So you can see that you can move some items like this bonnet, the gasket, and the tube bundle assembly to indicate for your customer how this equipment will be assembled. So as you see here, you can make a presentation by using Autodesk Inventor. One more option inside the Autodesk Inventor, which is the dynamic simulation. From several years, I did this study for the Lufkin pump. I make a manual calculation for that, and in that time, I prefer to make a comparison between the manual calculation and the dynamic simulation by using the dynamic simulation to compare the results. Here, as you can see, you can make a compare between the acceleration of rotation and the torque required to rotate this pump. So in the dynamic simulation tool, you can make a mechanical part, moving a mechanical part like the piston of the car motor, for example, and study the reactions on the shaft, study the acceleration, the the torque required, all of that. So you can study it by using the dynamic simulation tool, which included in Autodesk Inventor Professional. The frame analysis tool. We discussed the frame generator tool, which used to generate a simple steel structure. So if you would like to make analysis for this steel structure, you can use the frame analysis tool. You can say it looks like the SAB 2000 or STAD, something like that, but not professional like those. But you can use it in your simple studies to add loads and supports. So you can add a fixed support, roller support, or sliding support. So you will find many different options to define the case study that you have, adding forces, moments. After that, you will get the stress distribution on the each beam, and you can make a shear for normal or moment diagram for each part if you would like to create something like that. And by the way, you can generate a report for this analysis. By using Autodesk Inventor, you will be able to make finite element analysis studies. This tool, you can use it to make the finite element analysis studies, but if you would like to make it more professional, you can use the Nastran in CAD. Nastran in CAD is one of the applications of Autodesk. It's especially for the stress analysis, so you can make a mix between thermal and mechanical studies, linear and non-linear, dynamic or static. But in this tool in Autodesk Inventor, it's a separate tool inside Autodesk Inventor, so you can use it easily, but it's not include a huge capabilities. Okay, so you can use it if you would like to make or to prepare a quick analysis or to check something fast, you can use this tool. But if you would like to make it more professional, you may use Nastran in CAD, and the Nastran in CAD actually runs over Autodesk Inventor, so you will be able to open it from Autodesk Inventor itself. It will appear as a plugin. Some other features available on Autodesk Inventor, like which is the design tool. By using the design tool, you will be able to make a design for the power transmission systems, like chains, gears, shafts, springs, bolt connections, beam calculation, lathe calculation. A lot of things you can make or prepare a mechanical calculation with a report by using the design tool. Another important thing inside Autodesk Inventor, which is the Autodesk Inventor Studio. This studio gives you the ability, if you have a product and you would like to make a presentation for this product with a beautiful images or a beautiful video, like a real one. So you can get your product inside this studio and make a lights, add cameras, and define the material for the items. After that, start making beautiful images for your product to present it, like in brochure, for example, or something like that. Now let's start the next step in our presentation, which is the Autodesk Inventor interface. Here at the top, you will find the quick access bar. Now, this quick access bar, you can open a new part or open an old project, save the items, or go to the home for do undo, and you can add more features in the quick access bar. Like here, if you take a look, you can add like eye properties or sketch doctor. Some other features you can add it here. Here below the quick access bar, we have the ribbon. In this ribbon, you will find the features of Autodesk Inventor, like if you would like to make a sketch or create a solid model or change the application setting. Here from the this page will appear if you have the home page. And from here, by clicking on the gear, on the advanced, the gear button, and I will show you how we can do that, you can change the configuration of the default template. From this default template, you can change the units, the measurement units for your document, default document. So if you have a part, if you would like to create a new part, the default options for this part will be in millimeter or inches. So you can select the default option. You can select the default options for measurement units for your default document. The same for drawings. You have some different standards for the templates, so you can select the suitable standard. Okay, after that, you will find a get started form, and from projects you can generate a new project, and you can deal with the old projects. So by using this form, you can select an old project in your machine or create a new project on your machine. And there is some caveats during creation of project. The first one, the name that you will select for your project shouldn't include legal characters like backslash, start, question mark, or something like that. Because if you using something like that, the Windows itself will stop creating this folder. Okay, if we try, for example, making a folder including a backslash. So from folder, let's create a name and try to add a backslash. You will not be able to add a backslash or question or like a character like this. So don't use illegal characters during creation of your project. So how we can create a new project? So if you click on project, you will get this form, and from browse you can select the projects that you have like that. So you will find IBJ extension file. This file indicates the project location. So if you select it, you will move to this project location. So if you have any other location, you can move between projects by selecting the project and click on apply to move to this project, or by double clicking on the project itself, so you can move from project to another, like that. Okay, so if you would like to create a new project, you will click on new and you will get this form. From this form, you will get two options. The first one is a single user project and a new Vault project. The difference between them, the single project, in single projects, you will generate all the project yourself. That means you will not need a team to make this project. But in a Vault project, usually that's used in large projects, and you should have a Vault application. Vault application, it's Autodesk Inventor application, preparing the documents and numbering of items. So you will have a team leader, and this team leader will divide the project for his team. One of them, let's say, will make the equipment. The other one will make the piping. The third one will make the steel structure, and the last one will make the assembly of all items. So each one of those will have a task, and the team leader divide those tasks for his team, and one will make the assembly and preparing the final documentation. So you should have a Vault application to make this project and to give the team permissions. So, for example, the one who will make the pressure vessel, for example, will not be able to edit on piping, and if you reverse it, the piping one will not be able to change on the equipment or steel. So each one of those will have some restrictions, and the team leader will divide that. So the most of projects will be generated by using a single user, so that the common one, which is single user project. And by clicking on next, you will get this form, and from here you can define the project name. Let's make the project name like that, and define a location for your project. If you select the desktop, for example, to create this project, that means all files you will generate, it will be located directly on the desktop. That means if you create parts or assemblies, it will be laid on the desktop. So if you would like to create a folder to include this project, you have two ways. The first way to create this folder like that, okay, or you can after that you can select it from here, like if we minimize that again and make demo, okay, we have a folder here. After that we can select this folder from the desktop, so let's select this demo. So you can figure that you have this path now. So all of your folders and files will be generated inside this path, which is demo on the desktop. Okay. So if you would like to generate this folder from Autodesk Inventor itself, you can make a backslash like that and create new demo. So in that case, automatically Autodesk Inventor will generate a new folder named new demo, okay, and will create the parts inside this one. If we click on finish, Autodesk Inventor will inform you that this path does not exist, and Autodesk Inventor will create it. Okay, so if you click on OK, now you have a new project listed here in your projects called demo here, and here's the path of this project. And if we come back to the desktop, you will find this folder now created, which is new demo. And if you open it, you will find a folder called old versions, like the backup file for the AutoCAD. And this old versions, you will get a backup for parts and assemblies. And here, the IBJ file, which indicates the project location. And in the next slides, we will discuss the extensions or the files that Autodesk Inventor deal with it. Okay, now let's come back here and complete this one. Here. So as discussed, for the project name, it shouldn't include illegal characters. And the second thing, the names inside the project should be unique. What I would like to say here, for example, if you have a nozzle, this nozzle connected to a flange, okay. So if you make two flanges with the same name, but one of them for 2 inches and the other one for 10 inches, for example, they have the same name. You named it as a flange. Okay, one of them in another folder like that. You create a folder here for nozzle N1, for example, and nozzle N2. And inside N1, you add a flange with the name of flange, and N2 you create a part with the name of flange, the same name inside here. If you make an assembly, In that time, Autodesk Inventor will confuse and ask you which flange you mean. You have two parts with the same name. So the names inside your project should be unique, not repeated names, or no repeated names inside your project. Okay, now for how to navigate inside the right? How to navigate inside the 3D world. Okay, we have some tools we can use it to navigate inside the 3D world, which is View Cube. And this View Cube used to switch between a standard isometric view and the other views. You can click on the corner of this view to get the original views, or select the faces to select front or back or right view. You can rotate the view or select the home view. Let's check that. From here, let's open a new project. Okay, so let's open project like that. So the first tool, which is the View Cube, and we have another tool which is navigation bar. The navigation bar includes the navigation wheel, and we will discuss the options inside this navigation wheel. Band tool and zoom tool, orbit tool, look at face, and change between orthographic or perspective view and the shading style, and how you can increase this list on in the navigation bar. If we come back to the project again, and let's open this simply. Here, that's the navigation bar. If you click on the wheel, navigation wheel, you will get this navigation wheel here. It moves with the mouse like that. If you click on zoom and drag, keep clicking on it, you can make a zoom like that. If you click on review, you can move between the previous old views. Let's change that little bit by clicking orbit. You can move the view like that. Okay, by using walk, you can like a walk on the area. If you have, let's say, a structure or an apartment you would like to move inside this apartment, you can use the walk option. Okay, center, to change the center of the model, to make rotate around this point, so you can change the pivot rotating point, so you can move it to here. So if you make an orbit, you will make an orbit, and this pivot point will be at the center of the view. And make a look. So this one will give you the ability to change the look of view. Ban, you can ban the model inside the 3D area. Up and down, that's to change the level of looking. You can, as you stand up and sit down, so you can change the lookup view for your model. Okay, by using the other features here, you can you may not need to use the wheel. Like if you would like to make a band, just click the band tool from here and make a band for the 3D model. If we convert it to orthographic view and make a band, so you, by clicking on band, you can band the model inside the drawing area like that. And the shortcut for this order, which is F2. If you click on F2 like that, as you can see, you can make a band for the view. Here's some other options for zoom. like zoom all, which is zoom extend, you can make it by double clicking on the ruler of your mouse, fast double clicking like that. You will get zoom extend. If you zoom in like that and by double clicking on the ruler, you will get zoom extend. The same option, you can get it from here. Or zoom window, you can make a window to zoom for this window. You can make zoom select to select a part and make zoom select to zoom on this part. The orbit, you will find two options for the orbit. The first option, which is the free orbit, and there is three things you should know about the free orbit. If you select from the inside of the circle, you will find you have this circle and you have 4 lines. 2 of them are perpendicular, one at 0 degree, the other 180. You have another 2 lines on the, if we move that out here, you can figure that you have a line here and another on 270 degrees. So if you click inside this circle, drag and rotate, you will be able to make a free rotate for the model. That's in case if you select from inside the orbit tool. And if you select from the outside here, you will be able to rotate around the original axis like that, or from top you will be able to rotate around the original axis like that. That's 2 options. The third option, by selecting the circle from the outside, you can figure that the configuration of the prompt changed to rotate. So if you select drag and move, you will be able to rotate like that. So again, if you select orbit and inside, from the inside of this circle, you can make a free orbit on the space like that. Let's come back to the right view again. And if you select the lines outside here, those lines, you will be able to orbit around the original axis like that. If you select the circle from outside here, and the prompt shape will change, so you can make a rotate like that. That's for the orbit option. And for the constraint orbit, this constraint orbit, if you have a 3D model like that and make an orbit, it will keep the original position of the model around the original axis. But let's make the same thing, but with using the orbit option. If you make it like that, you can see it will not keep around the original axis. If in case of the 3D model, if you make an orthogonal isometric view, you will not keep the rotation around the original axis. But in case of using the constrained orbit, you will rotate it around the original axis like that. Okay, so we discussed the navigation wheel, the pan, and the zoom options. Discuss the orbit options. Now the look at option. Okay, you can make a shortcut, or the shortcut of this one is page up. So to look at a surface, for example, you would like to look at this surface, so you can select this surface to make it perpendicular or parallel to your screen. Okay, so by using the lookup, if we come back to the 3D model again, and you would like to look at this surface, make it parallel to your view, so you can make it by that way. So if you use this one, you can take a look to the view from here to there like that. So you will make the view parallel, this surface parallel to, or this plane parallel to your screen by using look at tool. Regarding the 3D view, you can make it perspective view or orthographic. So as you know, the orthographic, the lines will be straight, not ended to 0 at the end. But the perspective view, you can see the difference between them. So the perspective view, if you extend this line to the end, if we, for example, take a print screen, and let's try this. If you extend this line to the end like that, and extend that one to the end, they will meet at a point. The same thing here, if you extend a line like that, so you have an end point. So you can figure that the perspective view, you have, I think all of us knows the difference between orthographic and perspective view. Okay, you can change the focus of the perspective view. You can make it change the end point by, if you click on Control Shift and F3, and you can see that you can change the end point of the isometric or isometric view or the perspective view. Okay, so by that way you can, the focus of the camera where you are looking for, you can change it, make it more perspective by selecting 3 buttons at the same time, Control Shift and F3. So by that way you can change the focus point of your camera like that. Okay, one more thing here, which is the shading style. By the shading style, if you would like, you will find the different shading styles, and I think in your side you will not find the perspective or shading, but you can make it appear from here. You will find a customization button at the end of the 3D navigation toolbar. If you open it, you will find the projection and visual style. You can add them, so they will appear here on the navigation toolbar, which is the projection and visual styles. Okay, so that's the projection, and that's the style of the visualization style. The first one is the realistic one. Here you can see the true colors of the items that you select. And in case of selecting true colors, if you open the view panel, you will find here a button will appear, or this button will be activated, which is ray trace. This ray trace will give you an actual reality for the colors, and it takes a huge memory and a load on your processor, so we don't recommend it. But in case of you would like to generate an image or render the image, you can use it. So you will generate, as you can see, it takes a time to make a trials to render this image to make it looks like real. But we don't recommend using this if you are still working in your model, but you can use it if you would like to generate render the image in a certain time for your project. Now let's make display. And if you take a look, this button will appear only in case of real. So if we change it to shaded, this button will be disabled. Okay, so as mentioned, this button, which is ray tracing, which make a calculation for the light reflection, shading reflection, all of that, the colors when a light reflected to a surface with let's say a red color, it will make a reflection on the ground. So this reflection, all of that will be calculated if you select ray tracing. So this option takes a huge memory and make the your processor makes a lot of work to study this. Okay, if you so you will get the colors without any shading. The third option, which shaded edges, so you will get those black lines around the surfaces. Okay, and that will give you an indication about the surfaces, the end of surfaces of the item. One more thing, which is shaded with hide edges. If you select it like that and make orthographic, if you take a look, for example, you will find the shaded items and the hidden lines will appear like that. Another one, which is wireframe, so all lines will be as a wireframe like that. another option, which is wireframe with hidden edges. So the hidden edges will appear, and the wireframe or the visible lines will appear too. Another option, which is wireframe visible edges only. So you will get the wireframe for the visible edges only, no hidden edges in your model. Another shading style, which is monochrome. So it will be black and white and gray. So you will get a view like that. So another one, which is watercolor. Another visualization style. Another one, which is sketch illustration. As you can get as that, so the view will be as a sketched by hand. The lines will be lines sketched by hand, like that. Another one, which is technical illustration, like that. So here, so commonly we use the shaded with edges. That's the common one in using, or the shaded one without any lines. But for me, I preferred using shaded with edges, which is that one. So from here, we discuss on this slide, we discuss how to navigate inside the 3D world by using the view cube and by using the navigation bar, which give you the ability to rotate, pan, or look at face, change the view from perspective view to orthographic view, change the shading style. Okay, how to change the background color and how to display the default setting for your view. Okay, now let's open the tools button, and you will, from tools, you will find application options. So if you open application options, you will get this form. And from this form, you will find many things here. One of them is colors. So if you select color tab, you will find a list, which is canvas colors. You can select between them. And from here, you will find a list for the background. If you would like to make it as a one color, gradient color, or background image. Let's check the one color first. So you, from this list, select the color that you would like to make it as the back view for your model. Okay, for example, let's make it deep blue. And if you click on apply and close, you can figure that you change the back color of your model. Make it presentation again. It will be white again. In case of selecting gradient color, you will get a gradient color at the background. And by the way, you can change the gradient colors or create your custom schemes here. For the presentation, for example, if you select a gradient color and click OK, you will get a gray color at the top and white color at the bottom with a gradient color like that between the two colors. And if you would like to add a background, just select the background like that, click on apply. So you will have a background for your model like that. One more thing you can do, let's make it one color again. Here from the view tab, you can add for the lighting, for the appearance of the 3D model, you can add some of the standard lighting and locations. For example, if you would like to add an old wash house like that, you will be able to add a location as image around this car. You can change the setting of this one from here. If you open the setting, you can increase the scale. If we make it 200, for example, so the scale of this one will be changed. You can change the orientation of the location. So let's make it perpendicular to this car and like that. So you can change the image of this one. So if you have perspective view like that, you will be able to make a location like that. So you can this type of the setting of the let's say the environment around this area. You can change it like an dry salt bed, for example. Let's change the scale like that. So you can make those images interactive images. So you can make orbit rotate, not looks like a background only on the color setting. Okay, let's go to the next step. How to deal with the toolbars, how we can make them appear or disappear in case of needing to use it or not. If you open the View tab, you will find in Windows group a button here called the user interface. So any toolbar you would like to make it appear, if you close it by wrong and you would like to open it again. So any toolbar you disappear, if you would like to make it appear, automatically you will go to View tab. After that, the user interface tab. Okay. When you select user interface, you will get this list, so you can select the required toolbars in your area. For example, if you would like to make the view cube appear, you will select from here the navigation bar toolbar makes it appear from here, the model tab, and other tabs. So let's come back here, and from view, let's open the user interface. And for example, I close the iLogic tab here and the model tab from here, so to increase the drawing area. But right now I want to make the iLogic tab appear again. So from here, if you click on iLogic tab, it will appear. And by the way, it's you can make a drag and move for the form, so you can make it located on the left side or move it to the right side like that. So by using the this one, you can make this form appear or disappear. Let's make the background again like that. So from control panel, you will find some rules if you, and this step is for the professional level, which is making a coding and making a control panels to control the system. For example, it's a quick example. For the top part, for example, you can make a control to make things move like that. If you take a look, you can make a move for the parts like that. Okay, you can change the wire length, that's of the hook. So that's for the advanced levels. So you can make a programming and control the dimensions. Now let's make the 3D, the model browser appear again. So if you click on it from here, it will appear. So you can, as discussed, it's by drag and move, you can move it to the area that you would like to make it appear. Here, for if you would like to remove the view cube, so you can remove it by clicking on that, or make it appear again like that, so it will appear. So if you moved it, it will disappear, and if you click on it, it will appear again like that. Okay, let's go to the next step, which is the files that Autodesk Inventor deal with it. The first part, which is the IBJ extension. As discussed, to create a new project, you will generate an IBJ file. This file will indicate the project location and the project name, all of that. If you have an old project, you will have this extension file, so you can browse on it. So as discussed here, if you would like to browse for an old project, just click on projects and browse. So from here you can select the projects that you would like to indicate, like that, for example. So you have this project, now you include it, and the path of this project will appear here. So if you have an older project, you can browse on it by that way. So you will need an IBJ file to define your project. The second one, which is IBT, which is inventor part. I, the inventor for inventor, BT for part, so it's inventor part. So the extension of parts will be IBT. And we will discuss the type of parts, the types of parts. The third extension, which is IAM, which is inventor assembly. Inventor assembly. So the assembly will be a file, includes parts. Okay, so you need a parts to include it inside the assembly. The fourth one is IDW, which is a drawing file. Inventor drawing, IDW. One more file, which is IBN, which is inventor presentation. This extension, by using this type of files, you can make assembly for element, make it move like as we discussed on the previous slide. You can make things goes out and in to describe the assembly of the customer. One more extension, which is iNest. This is a file for nesting, and you will get this file in case if you have a nesting tool of Autodesk. Autodesk company produce a product called nesting. If you install this nesting tool, it will appear in Autodesk Inventor. So it uses Autodesk Inventor as a platform, so it will appear as a new feature in Autodesk Inventor. So in case if you have this tool, you will get this nesting files. So you can make a nesting studies for items and prepare the cutting sheets for multi-sheets arrangement. Now let's discuss the type of parts. In Autodesk Inventor, you can deal with the standard parts, which is solid parts. Like if you have a keyboard, the buttons of the keyboard, each button of those is a separate part. The casing of the keyboard is separate parts. So each part of those is a solid part. Parts which is sheet metal parts. Okay. The sheet metal parts will include some features that give you the ability to get blade development. So you can use some features like making a flat surface or a rotated surface, make a loft for if you have a loft connection as a reducer, for example. You can use those features to make sheet blades. After that, you can use the flat pattern order to get the blade development. So the difference between standard parts or solid parts and features of the sheet metal. And standard parts, you will not find sheet metal features, but in sheet metal, you will find the solid features and sheet metal features. So the sheet metal parts include the solids. If starting your part, you should decide if this part, a solid part, so you don't need the sheet metal features, or it's a sheet metal, so I will need the features of the sheet metal, because that will reflect on the file size. Okay. Therefore, the assembly, you will find the standard assembly and the weldment assembly. The difference between them, on the weldment assembly, you will find features for welding preparation, like if you would like to make a chamfer, make a fillet, make a hole for welding, and features to describe the weld, like a fillet weld or groove weld. So if you would like to make an assembly including those features, you will go to the weldment assembly. If not, don't make it. Don't use the weldment assembly. Use the standard assembly. around 90% of assemblies, I think you can make it with a standard assembly. Okay, the third one, which is drawing. You have two types of drawings Autodesk Inventor can deal with it, which is standard DWG with the same extension of AutoCAD, which is DWG, but it will not open on AutoCAD application. You can open it on Autodesk Inventor application only. And the standard IDW, this is the usual extension for the Autodesk Inventor drawings. Now, let's go to the next step and start creating a sketch to learn how to make the instances, 2D instances like line, circle, all of that. How we can start creating a sketch in the 3D world, because the 3D world you have space, you haven't allocated space or allocated plane to to start your sketch. So how you can deal with the 3D world and select a plane to start your sketch. Here, if you take a look to the model tab on the left-hand side, you will find a folder called Origin. This Origin includes the origin planes, which they are YZ plane, XZ plane, XY plane. You have the origin planes here. Okay, those origin planes are intersect. The intersect between those planes give you the origin axis. So you will have X, Y, and Z axis, which is the intersect between the three planes. And the intersect between the axis give you the center point, which is 0, 0, 0 in X, Y, and Z. So you will have origin planes, origin axis, and center point of the model. So let's open Autodesk Inventor, and from here you can start from the quick access bar. You can start creating a part, or from new, if you would like to create a new, you will get this form. And if you select one of those folders, you will get that form, and you can change the size of icons from here if you would like to make a detailed like that, or large icons or extra large. You can change the size of icons from here. As discussed for the part here, you will find the part. You will find two types of parts: the standard part and sheet metal part. And for the assemblies here, that's the assembly folder, you will find the weldment assembly and standard assembly. As discussed, for the weldment assembly, you can figure that if you take a look to the image here on the bottom right-hand side, two plates, and they are welded from here. But if you select a standard part, you will find an image indicate that you have a wheel, you have maybe a gear or a bearing or something like that here. So you have an assembly, not need to make a weldment. For the drawings, you will find two options for the AutoCAD or DWG extension or IDW extension. For the presentation, you will find this file, which is IBM, and you can find this image here. You can figure that you can move the parts to make a presentation for the assembly and the de-assembly of this file. Last one, which is the standard.inest, which is for nesting, to make a cutting sheet for plates. So this tool arrange the plates to save the raw material that you have. Okay, so this one will appear only in case if you have a nesting tool of Autodesk in your machine. Now let's start creating a new standard part. So from here, select standard part and click on create. Okay, like that. Or you can get it from the quick access bar. From here, click on this arrow and open part from here. Now we have this empty area. We have on a space. How we can start creating sketching, how we can do that. From here, from the 3D model, you will find a button here called 2D sketch, and you will find an arrow here. So if you open it, you will find 2D sketch and 3D sketch. For the 3D sketch, you can draw on space. So you can define the points in Y and Z, X, Y, and Z. But in 2D sketch, you will need to select a plan or plane to start sketching. So from here, let's select 2D sketch. And when you select it, automatically, you will get those planes appear. So you will get this plan, which is XY plan, a YZ plan, and XZ plan. They are appear here on the model tab. You have the origin folder here, and you have those origin planes and axis and points. So if you would like to start to create a sketch, you will get those planes, so you can select one of them to start creating your sketch. So if you click on the plan like this, you will get this start creating on that plane. Okay, let's take a look to the model bar on the left-hand side. Let's take a print screen and make a zoom for this. Here, as discussed, you will find the origin planes here, and you can figure that the color of that one become gray color. That means you are on the level of detail of sketch. Here you can figure that this color is white, but the other is gray. That means you are in level of detail on the level of a sketch. So now you are making a sketch. Okay, so we are on this level, which is sketch 1. So when you selecting creating a new sketch, automatically you will get this tab, which is sketch, and you will get those features. So let's discuss those in detail here. After that, we will come back to the drawing. Here the axis bar, quick access bar, the ribbon, and here you have the cube view and navigation bar, and the status bar at the bottom. This status bar will show you some important information, and during the session we will discuss the commands will appear here. And you have the model browser and the drawing area, which is a huge area on the middle. In this drawing area, you will find some axes. The original axis with the bold color, okay, and you have grid line axis, which indicates if you have for each 10 cubes of that, you will get a grid line and minor grid lines. Okay, so how to make those lines appear if you would like to use it in your sketching? Let's come back to Autodesk Inventor. Here you can figure that when we start a sketch, no lines appear here. So how to make those lines appear? From Tools, let's open the Application Options. Okay, so you will get this form, which we used it to make a presentation. Okay, so from here, let's open the Sketch tab. Okay, I hope you follow the steps. So from Sketch tab, you can select grid lines. Okay, so this grid lines, which is the main grid line. So if you click OK and close, you will get those lines here, which is the main grid lines. And if you select sketch and minor grid lines, if you click on apply, you will get the minor lines like that. So if you prefer to use this type, when you make a new sketch, that will be helpful for you. You can do that. So now we have on the sketch level, and if you come back again to the sketch tab, you can figure that it's with a blue color at the top here. Okay, so that means you are on the level of a sketch. So we will find create group. This create group includes 2D instances like line, circle, arc, rectangle, fillet, text, and point, and create a block. So if we come back here to this view, to this presentation, and discuss the 2D instances. Here on the create view, you will find a line. Inside this line, you will be able to create a straight line, create a spline by using control vertex, or interpolation spline, or equation curve, or bridge curve. For the three types, they are usually important, and the most important one is the line. For the second type, which is circle, or the second instance, the circle, and you will find three types or three different types of drawing circular part, and we will discuss that in detail. The arc, and you will find three different types of arc, and for the rectangle and the polygon slot holes, you will find the list of the rectangle shapes, and making fillet and chamfer, adding texts and points, and creating a block. Now let's discuss each instance of those and how we can create it. If we come here to the drawing area, and if you select the line like that, you can start drawing on the drawing area by clicking on the first point that you would like to start creating a line, and select the second point here. If you take a look, click on and when you click on the line, you take a look to the status bar here, you will find that it's informing you that select start of line. After that, drag of endpoint for tangent arc. So the status bar, if you are a beginner, will help you to know how to make this feature. So here, if you select the start point, after that, Autodesk Inventor will inform you drag and select the end point like that. So that's the first type of drawing a line. Let's make undo, and undo by using Control Z. Okay, and let's create a new part. We will learn in this step another way to create a part by defining the location of the first point in X and Y. So if you take a look here, let's take a print screen. If you take a look here to that, you can figure that this point, the located point that you stand on it right now, the location of this one in X and Y. So you can define the first point in X and Y. So from here, if we select the line, you can define the locations of X and Y, and you can move between them by clicking on tab. So let's select a line. So the shortcut of the line is L from the keyboard, or you can select it from here. So line or L from the keyboard to get shortcut, and to move to the level of editing the start and end point from tab. So you will be able to define the X location. So let's make it 5, and move to the Y location. Let's make it 10, and click enter. Now the first point located on 5 and 10. Okay, 5 in X direction and 10 in Y direction. Now you have the second point. Okay, and now you will be able to define the length of the line. So you can define the length of this line. So let's make it 20, and you can define the rotation angle of this line around the horizontal level. So let's make it 15 degrees. So if you click enter, now you will get this line with a length of 20 millimeters and angle 50 degrees from the horizontal level. And automatically, Autodesk Inventor will create a construction line. This construction line will help you in sketching. It's not, let's say, a solid line. You can use it in modeling. It's just for helping you in sketching. So we called it a construction line. So if you take a look at the type of this line, and when we select it, you will find this button is activated, which is construction line. This helpful line, not a real line. You can use it in modeling. Okay, That's the second way to generate or create a line. So the first way, which we discuss, by defining the location like that, roughly, or by defining start and end point like that. When you select a line by tab, you will be able to define the start point and define the length and angle. Okay. Now let's add a line. Let's know one more option for the line, which is making an arc tangent to line from the end. The line order can do that. How we can do that? If you draw a line like that, and at the end point, take a look at the color of the point. It's a gray color. If we move it a little bit, you will find it's the color changed to yellow. But if you come back here, it's become again gray. So let's take print screen to show you the difference between them. Yeah. Take a look. This, you will find it a gray with a gray color. So in that case, if you select drag and move from the left button on your mouse, the left button from your mouse, drag and move, you will get an arc tangent to the line from the end. Okay, and you can figure that the constraint will appear here. You can figure if we take a look. Let's make a print screen. You can figure that the constraint appear here for the tangent line. So by using this feature, you can make an arc at the end of the line by the same order, which is line. Okay. Creating a spline as a control vertex. You will be able to generate, if you select it like that, you will get a shortcut image, show you the definition of this item, like in line. You will get a shortcut definition for that. Here for this type of spline, which control vertex, the vertexes that you will select will not located on the spline, just the first and end point only. But the other points will be controlling vertices that will give you the ability to control the spline direction like that. That's the first point. So the first point will be located on the spline. If you add another line or point, sorry, you can figure that the spline will not move through this point. It's through tangent to the lines which you created by this those vertices. So if you would like to control the vertex, just or the spline curvature, just to move the line, and the spline automatically will be changed based on the change on the line like that. So the control vertex type give you the ability to change the configuration of a spline based on the lines tangent to this spline like that. The second type of second type of spline interpolation, which is the interpolation type, and in this type the nodes will located on the spline itself. So each node you will add, it will located on the spline itself, like that. If you click on create, you will get the nodes located on the spline itself. So if you would like to control each vertex tension or location, you can move it from the those buttons. So you can change the tension of this node, change the tangential direction of this node by that way. So you can change the tension of the spline, change the direction like that. So the difference between them, as discussed here, all points will be located on that one. If you would like to add more points on that spline to increase the smoothness of this one, you can just select the spline and you can add insert a point. So from here you can insert a points here. So those points you can control them, so you can change the tension, you can move them, so you can make it like that by using the new points that you insert to the spline. Okay. Regarding the other types, which they are the equation curve and edge curve, usually we didn't use those types, but to indicate where we can use this. For example, if you would like to make, let's say, an equation, define the sine equation or tan equation or something like that, you can write an equation to draw your arc by defining an equation, and actually something like that we will not use it, and that's in the advanced level. Okay, now so we discussed the three types of 2D instances, which is line, spline as control vertex, and spline as interpolation. Okay, here for the circle, you will find three types of circle. The first type, by defining the, if you select it, you will find here the status bar tell you that select center of the circle. You take a look here at the bottom, on the left bottom side. On the status bar, you will find the definition for that, which is select center of the circle. So if you click on the drawing area, you will get the center of the circle, and by that way you can define the diameter of the circle. So when you define the value, you will get a circle with a dimension like that. So you will define the diameter of this circle, and you can move it anywhere. Okay. The second type of circle, which is circle tangent to three lines. Okay, so to create that, we need to create three lines. So here we have another line like that, another line, and let's add another two lines, another line here. So we have 5 lines. So by using the second type, which is circle tangent to 3 lines, you will need to define 3 lines. So we select now 2 lines. When you select the third one, you will get this circle. You can figure that Autodesk Inventor make a preview for the circle before drawing it. So when you select the third line, okay, the red color means that this item not selected yet. So when you come near to this one, you will get this circle. Come near to this one, you will get this circle. And when you come to this near to this line, you will get this circle. So when you select it like that, you will get a tangent circle for those 3 lines. Anytime if you would like to change the line location or line dimension, the circle automatically keeps the circle tangent to the 3 lines. What looks like AutoCAD, because here you have an artificial intelligence keeps the information of sketching, of modeling inside this file. So any change or any parameter you will define it will be stored on this file. So this will help you to make controlled sketches. Okay, that's the second type of circle. So the first type by defining the center point and another point on the circle itself. The second type, which is circle tangent to 3 lines, and for the third type, which is the ellipse. Okay, so if you select the ellipse, you will find here select the ellipse center. So let's select the center of the ellipse, and from here you will find the status bar tell you select first axis point. So you can define the first axis, so you can change it like that. So that's the first axis. If you take a look to the status bar, select point on ellipse. So you define the center point, define the first axis end. After that, you will be able to select a node on the or point on the ellipse surface. So by that way, you can define an ellipse like that by using 3 steps. So again, define the center, define the axis end, and one point over the ellipse itself. Okay, now we go through the first instance, which is lines and splines, the second instance, which is circle and the other shapes, the third one, which is arc. You will find three types of arc. One of them is defining an arc by 3 points. So if you take a look to the image which appear here, you will define the start, end, after that a point located on the arc. So if we select this one, let's take a print screen to show you what I would like to say here. If we take a print screen and come here, you can figure that you will need to define the start, end. After that, the third point will be located on the arc itself. So from the arc here, you can add the first point, the end point. After that, the third point will be located on the arc itself, or the extension of like that. So you can flip the direction of the arc by that way. So that's the first way to draw an arc. A second way, which is arc tangent to the end of line. So let's create a line like that, or another arc. So from tangent, arc, tangent. If you select the end, you can figure that you will get notification with a green color here that you will select this point, and when you move here, you will get this notification. So let's take a print screen to show you what I would like to say here. When you come near to the end, the color of this end will change to the green color like that. So when you select that one or that one, you will get this point. So when you select it, now you will be able, without drag and move. Okay, in line, we use drag and move to make this order, but here, just select the end of the line and you will be able to create an arc like that. By the way, you can define the angle and the radius of this arc automatically during selection like pin, and by tab to move to the second text box. Now, if you click enter, now you will have this arc. We defined the arc angle is 60 degrees and the arc radius is 10 millimeters. So if you select the arc again, you can make arcs tangent to each other like that from the end. Okay, during entering, you can define the dimension of this. The third type of arc, like the tool of that you are using to draw a circle in real life. You will open it and define the center point. After that, define the diameter and start creating the arc that you would like to draw, which is called in Arabic bargal here. So you can make it like that. So define the center point, open the tool and draw the arc on the directions that you would like to draw. Okay, that's the third way to draw an arc. Now let's discuss the features of rectangle. Okay, the rectangle, you will find 4 types of rectangle available here. The first one, the difference between them, the drawing steps, okay, and the final configuration of this rectangle. Here for the this rectangle, you will define the start point and the other corner. So you will define one corner and select the other corner. So if you select this one and wait to this image, you will find that this type, to draw it, you will need to define 2 corners of this rectangle. So when you select it, you will define the first corner. After that, go to the next corner or the other corner of this line. Like you are making a line from here to there, and by using this line, you will make a rectangle. The second type of rectangle, which is you can rotate it or select the orientation of lines. But that one, the first one, one edge will be horizontal and the second one will be vertical. But by using this type of rectangle, you can control the orientation of the rectangle. So let's select it again. You open this one. You will need to make 3 steps. The first step, draw the first edge of this rectangle. So you will need to define start and end, which is 1 and 2. So let's still select, make a print screen and come here. So to draw this rectangle, you will need to make line 1, point 1, and point 2. After that, perpendicular directly, you will get a perpendicular line on that direction or the opposite direction to draw the 3rd point. So you will get this rectangle. So if you select it, you will be able to define the orientation angle. So as mentioned, you can define the lenses during importing data and the angle like that. So after modifying this, you can insert the width by that way. So you have this rectangle with the long edge with 40 millimeters, the short edge is 20 millimeters, and it's rotated with 30 degrees. Okay. The next type of rectangle, which is rectangle by defining the center point of the rectangle and the one of corners at the end. So, for example, if you would like to make a rectangle on the middle of something, so you will need to make it on the middle, on the original point. So by that feature, you can make the rectangle start from the center of this point. So you will select the center point to make this rectangle symmetric on the 2 sides, left and right, and symmetric on top and bottom. So, and sometimes you may need to use this type of rectangle in your sketches. Here, so we have this one. After creating it, you will find that you have 2 construction lines, which each line connect between the corners. Like that. The first line is a construction line, as we discussed. The type of line is a construction line. It's a helpful line only. Connect between the corners, like that. So that's the 3rd type. If we select the 3rd type, but you would like to make a rotate for the rectangle, like that one. That one makes lines horizontal and vertical. But if you would like to make it rotated, but in the same way you would like to make it from selected from the center of the rectangle, like that. So you can select the center, and here you can define the length and width. So that's the 3 steps. So the first step, which is selecting the center, okay, defining the half value of the rectangular length. After that, you can defining the width again. So that's the center, and from here define the half value. But the value on the text box, you will define the total length. But I mean here, you catch the half value from the center to the edge. Okay. Defining this, after that, you will be able to make this rectangle by that way. Okay, so we have 3 cases to draw a rectangle, 4 cases to draw the rectangle, and we discuss all of them. Now the slot holes. How to make a slot? There are 5 types of slot, and we will discuss each type separately. The first type, which is center to center. Okay, so in that case, you will define the center point to the second center point. After that, you will select a point located on the slot path, like that. Okay, so again, slot, define the center point, first center point, the second center point, and by that way you can define the 3rd point, which is located on the slot path. Okay. The second type of slot, by defining the start and end, the edges. You can see the line here located from the start to end, not from center to center. So the first type here defined by center to center, or that one from start to end. After that, a point located on the slot itself, like that. The third type, which is defining center point. So you can catch the center point here, defining the half length. After that, a point located on the slot itself. Okay, so we select the center point. Okay, after that, the center of one edges. After that, the third point located on the slot itself, slot surface itself, like that, defining the center. After that, the center of the second circle. The third point will be located on the slot curve itself. Okay, the fourth type, which is a slot based on an arc, not a line. If you can figure that, you have a line here. We have lines, but we have two another slots based on an arc. So from here, let's select start, end, and another point located on the arc like that, and you will be able to create the slot with like that. Again, here, like when the first type of arc based on 3 points. Okay, that's the first type of arc based on 3 points: start, end, and the third point located on the arc itself. That's the same thing here in slot. You will need to define the start, end, and arc point on the arc. After that, you can define the width of the slot, but by that way, like that. Okay, I hope this one clear. The fifth type, which is slot by, as you can use the tool of drawing the circles, like opening this tool, define the start, end. After that, the width of the slot, like that. So you have an arc here, and defining the offset of those edges from this arc. As mentioned, we have 5 types of slot. The last one on the rectangle, which is polygon. You can draw a polygon, and from here you can define the number of this polygon. If you would like to make a triangle, for example, so you will make 3. So you will be able to draw a triangle like that. So you have 3 lines, and you can figure that you select this triangle from the corner. So if we make a print screen and come back here, you can figure that the option here that you select here, which is selecting a corner. So if you come back here, you are selecting the corner of this polygon. So if you select the center point of the line, you can figure that now you are catching this polygon from the center of one of those edges, not the edge itself. Let's convert it again to edge. You can figure that you are catching this triangle from the edge, and here you catch it from the midpoint of one of those edges. You can change the number of polygon lines like that. Make it 8 edges, for example. So you can control the number of edges of this polygon like that. Okay. Now let's keep it like that. Now we have this polygon here, and that's the last option on polygons. Okay, so if we come back here, so we discuss the line instances, circle, arc, and rectangle. Now we will discuss some other features, which is fillet and the chamfer. From here, if you click on this arrow, you will get the fillet, and you will get this form here, which defining the fillet value. So if we change it to 10 millimeters, for example, and select the first line, and when you come to select the second line like that, you will get a preview for the curve that will be generated with a green color. You can get a preview for that. When you come near to this line, you will get a preview for this fillet like that, and you will get a value with 10 millimeters like you defined here. Okay, so again, you can make the same one by selecting the edge itself. So if you come near to this edge itself like that, no need to select one line and the second line, just select the corner. When you select the corner, you will get a preview for this one. Automatically, you will get this fillet in one click. No need to select one line and another line. Okay, so by that way, you can generate a fillet. Regarding the chamfer option, let's create a rectangle. So let's remove this one. And from sketches, let's create a rectangle. And from here, let's select a chamfer. Okay, you will find on the chamfer form 3 different options. The first option, which is the 2 values are the same. If we make print screen and here and zoom this one, you will find the value which is dimension 1 and dimension 2. They are symmetric. They are symmetric. So if you make chamfer with 10 millimeters and come to this corner here, you can make a chamfer with 10 and 10 millimeters. So they are equal by using the first type of chamfer. By using the second type, you will be able to define the chamfer on each line separately. So the first line you will select will be 10 millimeters. So the chamfer here, so we will select those lines, the relation between those lines. So the first line we will get 10 millimeters on this line, so maybe here, and on the second line 2 millimeters. So that's 2 millimeters, and the chamfer here is 10 millimeters. So the first line chamfer value will be 10. The second line will be 2. Okay. The third type of chamfer, which is the defining a distance and angle. Let's select this edge and make the value with 15 millimeters. Okay, or okay, let's make it 15 millimeters. So the first line we will select that line. So the chamfer will be here with 15 millimeters and will be with inclination with 15 degrees here. So it may cut here and the first point will be there. So if we select the first line and the second line, you will get 10 millimeters on the first line, and you will make a chamfer with angle 15 degrees like that. So you have 3 options to create the chamfer. The first one, which is make the 2 edges are equal, and the second one you can control the chamfer in the 2 edges. The third one, the chamfer value and angle on the second line. Okay. Now, making a text. Usually you can use this one if you have, in our field, if you have a nameplate or something like that, you can make a text over this plate to use it to define the equipment information or something like that. If you have a product and you would like to add your company name on this product, you can use the text feature to make that. So you have 2 types of text. The first type is adding a text as a straight text like that, and you, like in Word, you can control the adjustment of the text, make it on left adjustification or right or in middle, make it on top, bottom, or middle, make it in notes. All of that you can change the size of this one, make the stretch of the text, change the color, the orientation, all of that you can control it from here. But we have this text here as a straight text. So this straight text, you will not be able to make it suit a curvature arc. So Autodesk Inventor gives you the ability to make a geometry sketch which follows a spline or an arc. For example, if we have an arc like this, okay, and let's add a geometry text, and by selecting this arc, you can add a text like this and define the size of this one as 50, and You can control, make it start from left direction or right direction, make it up or down the curve, make it on the center, make it on the, like that. The offset distance from the start point, change the stretch, all of that you can change it. So by that way, the text will, you can make a text by that way. So for example, if you would like to make this offset with 15 millimeters, so you can change the options of the text, make it align to the right hand side, make it at bottom, like that. So you can change the options of, sorry, by changing this, make it for the start angle, let's make the start angle with 45 degrees. So you can change the options of this text. We make it at the bottom. Let's make it at top again and click on OK and just update this one. So you can, if you measure the angle here, you will find it 45 degrees from the start point of this one. Okay, so you can make a text adjusted to an arc or spline. One more option, which is a point. You can add points to your sketch. You can use those points as a pivot point to make a control. If you if you would like to make a controllable sketch like a mechanism or something like that, and that thing we will discuss it with the last option, which is creating blocks. Okay, so by using this feature, you can make blocks in your sketch if you would like to check some movable mechanisms or something like that. For example, let's create a circle, and let's define the circle diameter as 3 millimeters. And let's draw a line here. This line with make the value of this aligned value as 20 millimeters, and let's add another circle here with 3 millimeters, and let's convert this one to construction line. So this is a circle, you can rotate it like that. Now let's convert or make that one as a block. Okay, so let's make this block as, let's say, block 1. Okay, no problem. So we have this block here inside this sketch. We have this block, and let's make another, let's say, another part like that. Let's make it not horizontal or vertical, like that. Okay. Here. This one, let's make it a construction line. Let's define the there as 14, and we will discuss the dimensions and how we can add it and the constraints. Now let's make this part as a block. So from here, let's define as a block. So we have a block 2. Now you can figure that we have 2 blocks. Now let's make a relationship between this point and that point. So now you can move this block. You can figure that you can check your mechanism. If you have a piston, cylinder, or something like that, you can check the movement of your mechanism by making a blocks and make some relationships between that. And we could discuss that at the end of this session if we have a time to make a sample. But we need, before that, we need to know more about the constraints, which we will discuss, inshallah, during this session on the next slides. So we can make a block and make a movable mechanism to show you how we can use the create block. If you select it like that, you will get this image. Make a print screen and open. As you can see, you can make separate blocks here to study the movement as a 2D sketch, to study the movement of your block, and if you will get any clashes before proceeding with the 3D modeling, just 2D sketches to check the applicability of movement and the flexibility of your mechanism before proceeding with the 3D modeling. Okay. Now let's go to the next modifying features, which is modify and pattern and constraint, and how we can do that. If we open this slide and go to the next, so here, here we discuss the line features, discuss the circle instances, arc instances, rectangle and polygon slot. We discuss the fillet, chamfer options, text types, point options, and creating block. Here we will discuss the modifying orders, pattern options, constraints, insert options, and format options, which give us the ability to add center lines or construction lines or control the dimensions. After that, we will discuss the project geometry features. Actually, most of them used after creating a 3D feature. Okay, some of them used on sheet metal only, and we will discuss that in detail, inshallah. After creating a sketch, how we can finish the sketch and move to the next step. So let's come back to Autodesk Inventor, and let's close this part and create a new part, but at that time we will create it from the quick access bar, select a part. So the first time we generate it, we open that one, and from here, from templates, we select the standard one. And if you would like to open it from the quick access toolbar, you can open it directly from here. Now, let's create a sketch. As we discussed, when you click on a sketch, you will get the 3 origin planes, and you can select one of them to start your sketch like that. Now, to deal with the modify options, let's make a rectangle here, and we have a circle here. So if you would like to make a move for an item, if you open this one, you can move the item by selecting a point. So if we would like to move this circle, the center of this circle to this point here. So when you select the circle, okay, after that you will come here to select the base points that you would like to move from it. So select the point. After that you will select the next point, which the end location of this circle. During this step, you can keep the original one and make a copy. So you can make a copy from this circle to here and keep the original circle as it is. There are some other options, but those are using on the advanced option. So usually we will learn this in this step. Make a copy. It's the same as we discussed on move, but let's take a copy. So let's select the feature again, copy, select the feature and select the point, base point, and take a copy from here. But you can figure that you're still keeping the order. But in move, you will make it for one time. Again, so let's compare that with move order, copy move order. So let's select this one, and from here select base, select this point, and select a copy. If you select a copy from here, you will be able to make one instance only, and the form will be off. But in copy form, if you select the feature and select the base point, you will be able to make multi copies from this part during the selection of the copy feature. Okay, now the rotate option. Here, if we, let's say, let's make a polygon like that. And we would like to rotate this polygon 10 degrees. So the first thing you will select the polygon. So here, by clicking on rotate, you will get this form, which is rotate. And from select, you will select the polygon items And from here, select the center point. So you will rotate this polygon from the center, or rotate it from one of those edges. So let's select one of those edges, or another outside edge here. Let's select this one. So we will rotate all of that around this point, for example. So when you select this point, automatically you can figure that you can rotate this one, and the value will appear here. So you can define your value as this text box. So let's make it 50 degrees. So the orientation will be like that. Let's increase it a little bit. Let's make it 90 degrees. So the location of this one will be located at here. And if you would like to make a copy, you will select this text box. That will give you another copy from this instance with 90-degree orientation. If you click apply, you will have the original shape and the second shape rotated around this point. So the rotation option can be used by that way. Okay. The next feature, which is trim and extend. Now, if we have a line like that, another line here, and let's have an arc like that. So by using the trim feature, you will be able to cut a line up to the first intersect line, or the extent of this line by that way. If you select trim, when you select the end, you will get a preview for what will happen when you select that one. So when you come near to this arc, you will be able to cut the arc up to the first intersect point here. The same if you select the line, you will cut this area like that. Okay, so by that way, you can make a cut inside for lines, arcs, or splines. Okay, extend. The extend tool will give you the ability to extend the arcs or lines. So if we extend this line like that, and you select extend, when you select this arc, for example, you will be able to extend the end of this arc up to the first line or first arc to this end. Here, if you select this one, you will get a preview for this one. Like when you become near, you will get a preview for what will happen for this line, like that, for that line, for that line. So if you select the end from that side, you can figure that you will get a complete arc. You draw an arc up to this point from that side. Okay. If you make extend, you will get an arc from that side, like that. Okay. Now the split. If you would like to make a split to align this split tool, for example, if we have a line like that and have some points here, okay, by using the split tool, you will be able to make a cut on the on that line at the extension of that line here. You will get an intersect point here. So by that way, you can make a split. So you will have two lines instead of one line. You make a split at that line. So this point you can move it if we remove this constraint, and we will know how we can make that. But right now, this point is free now. It's not a horizontal point. So you can figure that you have this point is a pivot point like that. So you split this line to different lines, not one line. Okay. So by using the split tool, you can make a split on arcs or lines. Okay. The scale tool. By using the scale tool, you can select the feature. If we select this feature, for example, and selecting the base point. So if we select this base point, you can make a scale for this part. You can define the value here. So if you would like to make it 0.75 from the original one, you can make it like that. The same for stretch. If you select this one, select a point to make stretch, you can make a stretch for this on that direction by that way, like that. Okay, the offset option. If let's make a slot, for example, here. So by using the offset option, sorry, By using the offset option, you will be able to make offset inside or outside like that. One more thing, it's very important for the offset option, which is the loop selection. For example, you would like to select those 3 instances only, not the complete or the chain of this slot. Try this. When you select, you will select the chain, the complete loop of this one. But in your case, you would like to select 2 items only, not all the loop. So from here, if you right click, you will get this form. Okay. If you will find here a loop select. If you remove this one, this option, which is loop select, you will be able to select the instances that you would like to make an offset for them. So we select this one and that one, and when you right click again, you will find the continue. So you will be able to make an offset for those 2 instances only. Okay, so it's very important to know how to deal with the offset option with the loop option. So from here, we select those 2 instances only. The same if you would like to select those again, select them and continue to make another offset for those items. If you would like to get it back to loop, just right click and select loop select. Now when you select that one, you will select the complete loop. Now we discuss the modify options, which is move, copy, rotate, trim, extend, split, scale, stretch, and offset. Now to make a pattern, we have some options for the pattern. Let's delete those sketches and let's make this polygon, and let's get a line in that direction and another line in that direction. Now if you would like to make a rectangular pattern, okay, by clicking on this button, you will get this form, which will ask you to select the geometry. So let's select the geometry from here, and you will find 2 forms here, one for direction 1, the second one direction 2. If you would like to make an array, okay, in 2 directions, but let's try the first direction only. So let's select direction 1 and let's select this line. So you can figure that you will get an arrow here, a green arrow, indicates the direction of pattern. If you would like to flip it just from here, which flip direction, you can figure that the pattern will be on that direction. Sorry. And the arrow direction will change on that direction. Now let's make it the previous direction again. Change the number to 5 items and minimize the spacing between the items to 5 millimeters. So we have here 5 instances as a pattern with a spacing 5 millimeters between them, taking that direction. If we click OK, now if you change the line here, you can figure that the pattern direction will change during the changing the reference line or the reference direction. And that's the logic of Autodesk Inventor. Something like that. If you would like to make it on AutoCAD, you will need to use the parametric modeling, and that makes the file huge, little bit, and slow during the modification. But here in Autodesk Inventor, something like that is very easy. So, as mentioned, the orders that you will give it, it will be stored on this file. Anytime if you would like to change this pattern, if you select any of those, you will find the this pattern, and you can edit the pattern here. If you select the original one, you can make editing for the pattern. If you would like to increase the number of instances, make them 8, and if you would like to change the spacing to make it 4, for example, and click on OK, so you will get the pattern and like that. Okay, let's click undo. Now we make pattern in one direction. If you would like to make an array, you will need to make 2 directions. So from here, select the geometry first. So I selected the geometry and selected the first direction. define the number and the spacing between them. And for the second direction, you will select this line. Okay, so select this one, select the second direction. And if you would like to flip the second direction, as discussed from here, to flip the arrow direction, the green arrow here, you can flip the direction. So the pattern will be on the other side. So let's make it 8. And the spacing between them will be 4. So you have a pattern like that. Okay. And let's click on OK. Now you have this pattern. Anytime if you make a change to the line direction, automatically the pattern arrangement will change it. Okay, that's one of the most important things in Autodesk Inventor. Now, if you would like to make a pattern, sorry, for that one, for that direction, as discussed, but you would like to make them not associated. So you can control each one separately. Okay, so if you remove this one and click on OK, now if you select one of those, okay, you can make changes on each one as it's not an instance from the original one. Okay, so now you can see that you can make a change on the elements because this one not become an instance from this one. Let's come back and make again the pattern. Let's select this one and select that direction, and from here let's keep the associative, but now let's select suppress. Now you would like to suppress one of those features. Okay, the step that you have, let's make it then one. You have 1, 2, but the third one is suppressed. You haven't a 1 here. The step is not equal. So you can suppress this one, suppress this one. If you click on OK, you will have those features like the first one, but those are not an actual features. It's with a construction line, so it's not activated pattern. So the activated ones, those with the black colors. Okay, so by that way you can make a rectangular pattern. Let's make undo. Now let's make a circular pattern. If we have a point here, by the circular pattern, when you open this form, you will be able to select the geometry of the feature. After that, you will be able to select the center point of the rotation. For example, if you would like to select this point, or that point, in our case, let's select this point. Now you will get this pattern like that. And you can figure that the orientation direction will be counterclockwise. If you would like to flip it, you can flip it from this axis. You will ask me, it's the same, no change. That's because the angle here is 360. If you change it, for example, for 180, you can figure that the pattern will be on that direction if you make it on clockwise, but if you make it counterclockwise, it will become like that. So by the same way, if you would like to make it associative or fitted, you will be able to make it on that direction. You can define the spacing between them. If you remove the fitted option, that one, you can define the spacing between each pattern for the second instance. So if we make it 20 degrees, so by removing the fitted option, so the angle between the first instance and the second instance will be 20 degrees. So let's increase it to 30 degrees, 35 degrees. So you have this spacing angle between each instance by removing the fit option. Now that's the total angle from the first instance to the end instance. If you remove it, it will be the angle between each instance. I hope this point become clear. So again, here if you make it fit, So the total angle will be 35 degrees from the first instance to the last instance. But if you removed the fit option, that will be the space between the first and second instance and between the second and the third instance. So by removing this one, by the same thing, you can make suppress for some of those features. So the active lines will be that one, that one, that one, and that one, and those will be suppressed. So if you click on OK, so you will get this feature like that. Now, if you would like to make a mirror, so by using a mirror feature, if you select this one and select the mirror line, you can make a mirror around a line. So by selecting this line, if you click on mirror, you will get the same shape here. If you move the original one, let's say from the center line like that, the second instance will change because it's an instance from this one like that. You can figure that if you change the mirror line, you will get a movement. If you change the size of that one, everything will be interactive with you because there are constraints. You define them and you can make constraints on that. Okay, now let's come back to our presentation again. Here we finish the modify options and the better options. Now we will go to the constraint options, and it's very, very important to catch those features or those options because you will need to make correct sketches. So those features will give you the ability to make your sketch a flexible sketch if you would like to make it flexible, or a constrained sketch in case if you needed a constrained sketch. So you should have a good understand about each order of those. Okay, now let's come back here to the drawing area, and let's discuss the constraints here. Let's make a rectangle like that one. You make a roughly sketch, and you would like to make add the dimensions for this one. Here, if you select the dimension, by using this tool, you will be able to add a vertical, horizontal, aligned, angle, circle, radius, diameter, or radius values. So how we can do that? By selecting the dimension value. If you select this line, for example, and move up here, you will be able to define the horizontal dimension value or a vertical dimension value, but you would like to add the actual length of this line, not horizontal or vertical. So how we can get the actual length of this one? If you make a right click on this form, you will get here the aligned vertical or horizontal value. We need the aligned value, which is the actual length of the line. So from here, you will be able to add the aligned value or the actual length of this line. So when you select it, you can define it as 50 and click on OK. Now you define the length of this one. So in the memory of this file, this line all the time will be 50 millimeters. No way to change it unless you open this and define the value. But it will be all the time 50 millimeters. Okay. Now let's define the length of this one. So by selecting this one, and by the same way, you can define the horizontal or vertical, but we need to define the aligned length. Right click and select aligned and define that one. So let's define it as 20 millimeters. Okay. So we have this line like that. So that's the first way to define the dimension as aligned, horizontal, or vertical. Now let's add two lines. One like that, another one like that. 1 minute, sir. So we have two lines here, and to define the orientation between them, if you select the dimension option from here. If you select the first line like that, but that time we will select the second line. You can figure that you get beside the arrow a new icon for the angle. If we make a print screen, and let's come here. It's not print screen. Okay. So from here, if we you can figure that we have the angle icon beside the arrow. So in that case, you can define the angle between two lines by selecting the first and second line again. So from dimension, select one line, the second line. Now you will be able to define the angle between them like that. So you will be able to define the angle between the two lines by that way. If we have a circle like that, you can define the diameter of the circle by selecting the dimension. If you select the circle, you will be able to define the diameter. If you have an arc, we have an arc like that, and you would like to define the arc radius or arc diameter. From here, if you select this arc, you will be able to define the radius. But in your case, you would like to define the diameter, not radius. So if you right-click on this one, you will find a dimension type, so you can define the radius or diameter or arc length. So if you select diameter, you will be able to define the diameter of this arc. And if you select arc length, you will be able to define the arc length. So the arc length here will be 40 millimeters and the radius will be 30. So you make a control for the arc length and the radius of this arc. So by that way, we learned how to make a dimension for lines, use it to make an angle, make an arc length, or define the radius and diameter for a circle. Okay, now let's go to the next step, which is making another constraint. So the dimension is a constraint because it's fixing something. When you add a dimension for something, you will fix it. Okay, fix it by that dimension. Like as we said, when you add 50 millimeters to that line, this line length will be 50 millimeters. No way to change it unless you open this form and change this value. Okay. Now let's add another constraint, which is coincident. This order, you can use it to connect between 2 points, make a point welded to another point. Like when you select this one and select this point, you can figure that the color of this point changed to red. When you select it and select this one, you will make a connection point here between this arc and the line here. So you can figure that they are connected from here. So they will be welded. So this order, you can use it to connect points to each other. So which is constant, you can use it to connect 2 points with each other. Okay, now the second one, which is collinear. Here, if we make a rough sketch like that, to give you a good understand about the aligned options. The collinear option give you the ability to make lines collinear to each other. So if you select this one and select this one, you can figure that they are in the same level. So here, and the constraint will appear and stored on this line. You can figure that this line is perpendicular to that line is collinear with that one. Okay, so the constraints will be stored here. Okay. If you would like to make this one collinear to this one, so when you move that one, the other one will move with it, like that. Let's add another collinear option between that one and that one. So the level of the 3 lines will be as the same, like that. Okay, and if you select one of them, you will find that this line is collinear with that one, and you can figure that the color changed to red. So that means this line collinear to that one. And when you select this one, that will indicate that this line is collinear to that one. Okay, so anytime you would like to delete one of those constraints, just select this constraint and right click and make it delete. So here By that way, you can delete the constraint, the stored constraint between that line and that line. In that way, you can move it as a free. But if you make it again, constrain that one with that one, they will be in the same level, like that. Okay, one more thing here, which is centered. If you have, for example, a circle, we have a circle here, and we have another arc at this area, and you would like to make this circle center line located on the center line of this circle, just by selecting the concentric order and select this arc, select this circle, you can figure that they now get the same center line. So the center lines now become located on each other. One other way you can do it by selecting the first order that we talked about it, which is coincident, by moving the center line of this one to the center line of this one. It will give you the same result. Okay, so collinear, you can concentric, you can use it to make center lines for circles in the same point. Okay, one more constraint features, which is fix. By using this order, you can fix a point or fix a line, so it will be fixed on the drawing area. For example, here if we try to select this point and move it, you can figure that the rectangle will move with us like that. But when you select a fix and select this point, now this point you can figure that it's fixed. You can see this lock here. So if you try to move this rectangle, you will not be able to move it because this point is fixed. You can rotate it around this point, but this point will not move up or down, right or left. Okay, so you, by using the fix option, like here, if you would like to move this circle, you can move it, drag the circle and move it. But when you fix it like that, you will not be able to move it. And you can figure that the color changed from black to blue. That means this circle become now fixed. No way to move it unless you remove this constraint. So let's come back here and select this point, and you will get this constraint here. If you right click on it, if you select this one and click on delete, now you can figure that the color of the line become black again, and now you will be able to move the circle. Okay, so we discussed the coincident, linear, centric, and fix option. Now let's discuss the parallel. We have lines like that, and you would like to make those lines parallel to each other. From here, if you select parallel and select the first line and second line, you can figure that you have a parallel order between them. So if you try to move one of them, the second one will be parallel to the original one. The same thing if you would like to make a perpendicular relationship. So if you would like to make this line perpendicular to that line, you can figure that this line moved and become all the time perpendicular to that one. And if you would like to measure the distance, the angle between them by using the dimension, make that like that. When you try to add the dimension, you will get this message, which inform you that you make an over constraint because you already defined the angle between them. You already defined it as 90 degrees because they are perpendicular. So adding one more constraint looks like another. All the constraint will over constrain the sketch. So when you click on accept, you will get this dimension around brackets. So if we make a print screen and open that one, you will find two different shapes of dimension. The first one, which is dimension between brackets, like that, and another one dimension without brackets. That type of dimension, which not include any brackets, you have the ability to change it. But that one, you will not be able to change it because it's constrained by another constraint, which is the perpendicular constraint here. Here you defined a perpendicular order or perpendicular constraint, if you select this line, you already have this constraint, which is perpendicular. So that dimension will be a driven dimension. But that one, anytime if you would like to change it, double click and change the value, it will change. But that one, if you try to open it, it will be disabled. So no way to change it. Okay, because you already defined you have those two lines are perpendicular. Now, if you would like to change this dimension and delete this constraint, as we discussed, you will select this constraint. Just select this constraint and click on delete. Now, those lines will not be. If you can you see the value of the angle changed, but still this value is a driven value. So if you would like to change it in that time, you can select it from here, and from the format you can remove that driven dimension option. Now you will be able to define this value like that by removing the driven dimension value. Okay, now let's go to the next step, which is making the horizontal value. So by selecting horizontal and select this line, you will be able to make it in a horizontal position like that. And if you would like to make it vertical, just select this line to make it in a vertical position. And you can figure that the second line angle from this line will be 120. Because as we discussed, all constraints you will make it will be stored on the file. Okay, one more option, which is tangent order. If you have, for example, if you have a circle like that, and you would like to make this circle tangent to this line or tangent to an arc, if we have an arc like that, let's make an arc like that. So if you would like to make this circle tangent to that line, so you will get it like that, and you will get a new constraint here. Or if you would like to make it tangent to this spine like that, so you can figure that it's tangent. When you move it, it's move with the extension of this arc. So if you extend this, all the time this circle will tangent to the extension of this arc. Okay. One more option, which is smooth, usually used if you have a spline. So if we have a spline like that, okay, and you would like to make the end of this spline smooth at the end here with that line. So by selecting smooth, you will select that one and select the line. So the end of this spline will be smooth with that line at the end. So the smooth usually used to make the end of spline smooth to an end line. Okay, for the symmetric option, we have a circle like that and a line here and another circle there. So by selecting the symmetric option, you can make this circle looks like this circle around the line. Again, by using the smooth option, symmetric option, you can make this circle looks like this circle around the line. So select the first instance, select the second instance, select the mirror line. So in that case, if you change location of one of them, you will be able to change the other. If you select the diameter of one, the second one, because they are now symmetric. Okay, now the equal order. For the equal order, it's very important. Instead of making a new dimension, you can select equal. So in that case, if you would like to make this line equal that line in length and that one equal to that one, you can do that. Or by selecting all lines in one time, so select those like that and make them equal. So in that case, those lines, if you change one of them 5 millimeters, all other lines will change. Depends on that. Okay. So those are the constraints which used to fix the sketch or make sketch flexible in case if you have, as we discussed, have a blocks and you would like to study the here. If you have a block, you can use those constraints to make to connect your blocks with each other and study the movement or the if you have an intersect for your mechanism or something like that to study the mechanism. So you can use those features to fix your sketch or make it flexible. Okay. Okay. Now, if we come back here, so we discuss the modify features, the pattern features, and constraint features. Now let's discuss the insert and format features. Now let's discuss how to insert an image. So from here, if you select this image, you can figure that you, for example, you can add a barcode if you have a product like biscuit or something like that. You can add the barcode on this one, and you can add your logo, your company logo, or something like that. You can add it from here. So from images, let's open this one, and let's come back to here and like that. So logo, and select SEG logo like that. So we will have this image like that. So you can define the length of this image, and you can define if it's vertical or horizontal. So you can import an image to your file to use it during your work. And one more thing you can do it, which is importing points. Let's close this file and let's open a new part. And from here, let's create a new Excel sheet in X and Y. Like we have the first point in 0 and 0, second point 10 and 10, the third point will be 20 and 50, the third one 30 and 100, another point at the end 150. So we have those points in X and Y. Now if you would like to import that, let's create a sketch first. Usually you can use that if you have, in our industry, which is oil and gas, you can use it if you have a tube sheet and you have the location of tubes in X and Y location. So you can import this Excel sheet to your model. Okay, so you will get the location of holes inside on the tube sheet. So you can use it to generate the tube holing in case of a tube sheet. So that's one of cases in our industry. Okay, here let's import this Excel sheet. So from points, let's open this one and go to the desktop, and select this Excel sheet. Now you can figure that you will have those points like that. The first point 0 and 0, the second point, third, fourth. I hope the points be clear on your side. Okay, so let's select it again. But during the selection, let's make an option here, which is create, align, or spline. Now, from options, again, we have a sketch, and from points, let's select the Excel sheet. Don't click on open directly. Just open the options, and from here you will find different options. The first option, which is create points only. So in that case, you will create the points based on the points in Excel sheet. But if you would like to link between the lines, link between the points with a line. So with lines, so you select create line, and when you click open, now you can figure that you create lines between points like that. Let's make it with a spline. So from points, let's select the Excel sheet, and from option, let's select create spline and create open. Now you can figure that you create a spline based on this those points. You can use something like that if you have a location of a piping or something like that on 3D, so you can use that on 3D. Let's click on finish, And on the 3D sketch, let's discuss that here. And let's add each point in X, Y, and Z. Now we have a location for each point on space, not in X and Y. And here we generate a 3D sketch. So let's delete this sketch. Let's finish the 3D sketch first and delete it. And now let's come back here to the 3D sketch level. And from here, let's create a spline on the 3D like that. It's not saved yet, so let's save it. So import that one. We import them as points. Let's import them as with connected lines. So from here, let's create a connected lines. So you can figure that the line path on the space, because we defined each point. If you take a look here, we defined each point in X, Y, and Z. Again, if we import it as a spline, you will get a spline connect between points in space. Okay, so here we learn how to import an Excel file to the 2D sketch on the to your file, and how to import an image. Now, how to deal with the AutoCAD drawings. If we let's create a new AutoCAD drawing. During the opening of AutoCAD, let's discuss something regarding the format. Here you have three types of lines. The drawing line, which is an original line like that, and the construction line. So if you select one of those and convert it to construction line, so that line will be a helpful line, not used in modeling 3D features. It's just a helpful line. The third type is the center line. So you can make this line as the center line, so you can make it as a reference if you would like to rotate something in space. And we will learn that, inshallah, on the next session, and how to make 3D solids by using the features of 3D modeling. Here we have this CAD file. Let's create start drawing, and let's draw a circle. Let's make a line from here to there, something like that. Okay, let's make a trim. Let's trim this and save this file on the desktop. So let's save it on the desktop as DWG and save it. Let's close the AutoCAD and come back here to Autodesk Inventor. And from CAD, let's open the desktop, browse on the desktop, and select the drawing. Okay, now let's click on Open. Okay, it will inform you that it's not located on the location of the project. It's outside the project, but no problem. That's the message which we receive. Now we will receive a form. This form indicates the layers that you would like to import. If you have more layers here, like a visible layer, a hidden layer, hatch layer, you will select the layers from here by selecting all layers. After that, you will be able to import your sketch. If you click on next, the detected units in inches, if you would like to specify another unit like centimeter or millimeter, so you can deal with this form by changing the units of that one, and by clicking on finish, you will get the sketch here. Okay, but you may need to make a new constraints, because as mentioned in AutoCAD, no constraints. So if you move this line, it will be moved. If you move this line, it will be moved. So let's add some constraints here to test what we learned for the constraints. So let's use the first constraint, which is constant, to weld the points here and there. So we have those lines. And the second thing, let's make a parallel, so that line will be parallel to that one. Another one which is perpendicular, so let's make this line perpendicular to that line. Okay, by the way, when you make this one perpendicular to that one and that one is parallel to that one, that means this line is perpendicular to that one. Now let's make another constraint which is tangent. So this line will be tangent to this circle, that line will be tangent to that circle. Now you have a constrained sketch. Just you will need to define the dimensions. So this is 10 millimeters, and from here to there it will be 20 millimeters. So now this sketch, if you move it here, now you will be able to fix it. And if you wanted to define an angle, let's draw a construction line. We draw a horizontal line, and let's convert it to construction line. Now you will be able to define the tilting angle of this one, and you can figure that this sketch become now fully constrained. Okay, because this sketch now, if you try to move it, it will not move because all constraints make this sketch is a fixed sketch. Okay, that's the third point on the insert. We insert image, points in 2D and 3D, AutoCAD drawing, and discuss the type of lines and dimensions. And we discuss the driven dimension during this session. Now, after finishing the 2D sketch, we would like to finish this sketch or go outside this sketch. How we can do that? By clicking on Finish Sketch, or right-click here and select Finish Sketch, Finish 2D Sketch. Okay. If you click that, you will go to the level of the Model tab. Now you will be able to make a 3D feature like extrude, that, and we will learn how to deal with that on the next session, inshallah. You will be able to make rotate or that, like that. If you would like to make a rotate, all of that, you end the finish and go to the next step, which is creating a 3D model by using the 3D feature. Okay, now let's come back to this slide, and here let's discuss the projection geometry orders. Here for the projection geometry, it will appear only in case if you have a sketch. So if we come back to the sketch level by clicking on the sketch from the tree, by selecting the sketch itself and double click on it, you will come inside this level of editing, and now you have this sketch. And from a geometry tab, you can project some features. Like if you would like to print the y-axis, if you select the y-axis from here, you can figure that it will appear on the drawing area. So if you project it, you will get a line like that with a yellow color, like that. Or if you would like to print the z direction, you will get a point because it's perpendicular to the plane. Okay. So we will discuss that when we have a 3D model, because those features usually used if you have a 3D model, and some of them, which is project flat better if you have a sheet metal part. So need to use this in case if we have a 3D model, and we will discuss that inshallah in detail on the next sessions. Okay, let's come back to this slide, and with the last slide here, we need to discuss the we need to discuss the how to change the document units. Okay, here in the document setting tab, in the tool tab, in the ribbon, you will find document setting. In this document setting, you will be able to modify the settings of this document, like changing the length measurement value or unit. The same for mass, if you would like to make it in pound or kilogram or milligram or something like that. So how to change that? From tools, if you open document setting, okay, and if you from units, you can change the measurement units from inch, foot, center line, millimeter, meter, or micro. For mass, you can change from pound grams, kilograms, and the precision of units, drawing and angular precision, if you have an angle. So you can control the precision of entering data. Okay, now we have an example. And in this example, we will create one of them on a drawing, not on 2D, to show you that you can use the Autodesk Inventor drawing to create 2D sketches like in AutoCAD, and it's intelligent, not like in AutoCAD. After that, you will try to repeat that from your side, and I will make one of those, and after trying from your side, you will flip the screen to your side to check what you can do. After that, I will proceed with the second one, and we have some other cases to do during the next 1.5 hours to check that. Let's close this part, and let's open a drawing. So from here, let's open that one and create IDW drawing. So let's select standard IDW drawing. Okay, here in this drawing, you will have a border and title block. If you take a look to the drawing area here, let's open this and sheet format. Let's open that and make a print screen for that. Show you that in detail. Okay. Here, that's your drawing. Okay, inside this drawing, you will find some resources. Those are the resources in your drawing. Okay, the resources divided to the sheet format, which including the size of the sheet, okay, and the borders. So you can import your standard borders here on this list, and title block. Okay, another one which is sketch samples, like the blocks, standard blocks in AutoCAD. In our industry, we can use for the north direction sample, the welding detail samples, all of that you can add it to sketch samples to use it as a reference sketch. And in title block, you have the ability to define the your title block. Here you will find the standard title block. That's it, the title block here. So you can draw and define the title block, your standard title block, and the same for the border. Okay. Those are the references. So let's minimize the resources or references, and here we have this sheet. Okay, this sheet we can deal with it by modifying it. If you right-click and get edit sheet, you will be able to define the sheet name and change the size of this sheet. Let's make it A2 sheet. Okay, so automatically you will get the height and width of this one. You will be able to change the title block location. You can make it at top, bottom, right. You can make the sheet as portrait or landscape. Okay, so let's make it A2 and click on OK. So you can figure the size is changed now. Okay, now let's start creating this drawing. So we will start creating the image on the right-hand side with hatch, this one. So let's discuss how we can or how we can draw it. At the beginning, we have a circle at the middle. It's a complete circle with a diameter 26 millimeters. So on this drawing, let's create a new sketch. Okay, so from here, let's create a new sketch and start creating a circle with 26 millimeters diameter. So let's make it like that. During creating this circle, we define the diameter. So again, so from here, select the circle and define the center line. And now you will be able to define the diameter of this circle. So it's 26 millimeters. We have this circle now. Oh, okay. Now we have another circle, which is, it's not a complete circle, which is 80 millimeters diameter. So let's draw another circle with, by another way, by after making it roughly, Okay, after creating it as a roughly, okay, you can add dimension, or you can add dimension during importing it, like we did with the first circle, or you can add a roughly value like that. After that, you get the dimension and define the diameter of this circle. So now we have those two circles. Another circle at that level, if we make a print screen and come here. So we we draw this circle. Let's increase the thickness of the line a little bit. We draw this circle, okay, and draw the second circle, which is that one. And let's draw this circle, which defined as 64 as a radius, and another circle with 80 millimeters radius. Okay. Now let's add another circle. So the diameter of this one will be 64, like that. You can make an equation, not only the value. So Autodesk Inventor can calculate that. So 64 items 2. So that way, here that's the value. Okay, 182. Another circle, which is, if we open this one, which is 80 millimeters radius. So you can edit it like that, 80 items 2. So you have another circle for that one. So we draw those circles, and now we need to make a slot hole on an arc. Okay, so we need to make a slot here, which is that slot. Okay, we need to make that slot here based on this arc that we have. So let's come back here, and from rectangle, let's select slot, this type of slot, and define the center line. And from here, let's define the center, and after that, define the width. Okay, so here we have this slot, and we need to define, sorry, let's close this Excel sheet. We don't need it now anymore. Here, you have the radius of this one as 16 millimeters radius. So if we select this one and define that one as 16 millimeters, we will get this slot length. If you try to select the end point and move it, it will be moved like that. But in the drawing, it's defined it as 30 degrees here. So we need to make a constraint for that. So if we come back here and draw two lines, like that, one of them is vertical. That one is a vertical. You can figure that. And the second one will be on 30 degrees. So let's find that as 30 degrees. And we need to make this point located on that line. Okay, so you can figure that this point located on that line. Now you can figure that the second end will be moved. Let's fix this point at the middle. We need to fix this point to avoid moving on the drawing area. So let's fix that. Now you can figure that if you try to move, the end of a slot will be moved. You can make the same feature by drawing another line with 30 degrees and coincident to this point to this line, but we will make it by using another feature, which is, you can see the vertical option. Okay, so the vertical option, you can use it with points. How we can use it? So we will learn now this step how to make a point vertical to another point. So let's select this feature and select the center point on this arc. Make it vertical to the center point here. In that case, that means this arc, you make the midpoint of this arc vertical to the center point here. So in that case, you will not be able to move that circle. Now let's convert those circles sketch. They will appear on the sketch only. The same thing for lines. And now let's finish sketch and take a look to that sketch. So those lines will appear only on the drawing, and let's convert this arc as a sketch the same. Now we need to make the outside curve here and there, this curve. How we can make it? We learn the offset option. So if we select this offset option, when you select that one, you will be able to make the whole chain of this slot. But in our case, we don't need all the chain. We just only the outside arcs and the top one. So from here, let's remove the loop select and select this one, that one, and that one. So we'll select those arcs only. And from here, let's click on continue. Okay. So by that way, you will be able to make an offset for those 3 arcs only, not all arcs. Okay, so we have this one, and now let's define the thickness of that one. So the outside circle diameter here, the circle here is 108 millimeters radius. So from here, if we select the dimension and select this one, we can define the outside diameter 108 millimeters radius. So we will get this one. Now those arcs, you can move them like that. They are not catching with anything, so you can move them. And by the way, you have an fillet here. If we take a look to the image here, we have this circle, and we have here a fillet between this arc and that arc. We have 2 arcs, arc here, okay, from here to there, and we have another arc between those arcs here. So at the beginning, we need to draw an arc, start from here to there, okay, and we need to make an arc tangent to those from here. So let's select an arc, the first type of arc, by defining 3 points. So by that way, we make an arc here, and by using the constraints, we can make this arc tangent to that one, like that. And you can figure that this point is not connected. So by using coincident order, we can define the connection from here to there. Now you will be able to define the radius of this arc, which is 10 millimeters. So let's come back here and define the radius, which is 10 millimeters, like that. And you can make a mirror for those arcs, like that, around the vertical line. So if you select mirror and select mirror line, you will get those arcs here. And you can figure that you will need to connect those lines. So if we select those lines like that, so you will get that one. And for the arcs at the end here, they are the end of those arcs here, not at the correct location. So we need to make another line, horizontal line. This line will be construction line. So let's select it and convert it to construction. And now let's mirror the above lines and circles that we draw. So let's select those, select that one and that one. All of that, let's make a mirror around that line. So we will get that feature here. Now, if we click on finish sketch, you can figure that those are not connected. We need to connect them. So let's come back to the sketch, and by coincident, let's connect the end of this point to that one, and the connect of this point to the end of the line. So where is the end of this line? So let's click finish. Now it's, because that one is mirrored to that one, it's okay now. Okay, now, so by that way, we draw this sketch, and we need to make a hatch inside this and make a line tangent to, we have, if we make a loop, we have a tangent lines here to this circle. We have a tangent line to this circle and that one. So how we can do that? If we double click again to the sketch and select a line, and if you select this arc and drag and move by using drag and move, select the first point and drag and move. Now by that way, you will be able to make a sketch, make a line tangent to the second line like that. By that way, or you can draw a line anywhere like that. After that, by using tangent, you can make it tangent from here and there. And you can use the same line and make a mirror for that line around the vertical line here. So Now we get this sketch. Now let's make a hatch. So by clicking on hatch region, when you let's convert those lines to construction lines. They are already construction lines. So because they are not connected, we need to connect them here to there. So this one. Okay. So it's sketch. Need to make to check where is the opening point. Okay, now let's finish this and let's add some center lines and dimensions to this feature. Now, from here, if we open annotation and from this type of center line, and we will discuss that during the drawings and how we can do that in detail. But right now, if you would like to make a center line here like that, you can make it by that way. Okay, and define the dimensions. So that's the inside diameter, and that's the if you would like to make it as a diameter, not a radius, you can make it like that. Define that one. Okay, define the width of this one or radius of that one, and how to control the precision and the this comma. All of that we will discuss it from the manager setting, how you can adjust the style of the dimensions. Okay, the 30 degrees angle here and there, like that. So you can define your sketch by that way. You can move it anywhere by like that. So you can use the drawing part as AutoCAD, and you can figure that it's anytime if you would like to make a change, just come back to the drawing again. And for example, if you would like to change this angle to 40 degrees, automatically when you click finish, automatically the values will be changing. So it's a flexible sketch or a parametric sketch. You control on it by using features. How to change it? Okay. Again, if you have a document like this part or that assembly, the default option will be the options that you defined it from the home setting at the beginning. As we discussed from the home, we make the default option as millimeter, and the drawing default will be ISO. But anytime if you would like to change that from your document, if you have that's a part of document, from tools, okay, you will select document setting. So you will get this form, and from this form you will find the units. So you will be able to change the measurement units from millimeter to inches. So the default value here is millimeter. So let's try to make it in inches and click on OK. Now if you create a new sketch here, and let's create rectangle like that. When you add a dimension here and click OK, you can figure that the unit here is in inches. So if you defined any value, like make it 2, click OK, it will be in inches. If you double click, you will find that. One more thing here is very important for the parametric modeling. You can write the unit by hand. Like if you would like to make it 20 centimeters, so you can figure that, you make it 20 centimeters. You click yes, automatically it will appear like that, 7.874, which is the convert of 20 centimeters to inch format. Okay, you can figure that here. So you defined it in centimeters, but it will appear here in inches because the document units in inches. Okay, so let's try it with another value. Let's make it 1 foot. Okay. Input here. If you click yes, you can figure that it's now 12 inches, but here you defined it as 1 foot. So you can define the unit. If you don't like to convert by hand, you have a different units, and you can write the value by hand: centimeter, millimeter, micron, or foot. Okay. I hope this point become clear now. So the document unit, you can change it from tools, document setting, and from units you can change the units of weight. If you would like to check the weight in kilograms or grams or something like that. For example, let's extrude this part for 10 inches and click OK. And it changes the material of this one to steel. Now, if you would like to measure the mass or from the physical properties, we will discuss that on the next sessions, inshallah. But I would like to show you something here regarding the mass. If you update this one here, this one mass or weight will be 121 kilograms. Okay, so that's the weight of this part in kilograms. If you change the from tools, if you change the units of weight measurement, if you make it in pound and click on weights and click on update, you will get the weight in pounds like that. And you can get the area, surface area for the 6 faces and the volume of this one. And here that's the specific gravity for the steel. If you change it for rubber, for example, you will get another specific gravity and the mass will be changed automatically. And inshallah, we will discuss the properties of the items, because it's very important in 3D modeling, because if you have some mechanisms or something like that, you will need to get the center of gravity and the weight of the actual weight of items. So you will need this step. It's very important, and inshallah we will discuss it in detail on the next sessions, inshallah. Okay, now let's go to the next sample that we have, and let's draw this part. Here, let's create a new part. Okay, and create a new sketch, and let's select this plane, and from here let's draw the inner circle, which is 22 diameter. So we have a circle here with 22, so we'll define the center line and the diameter of the circle. It's millimeters, and another circle, which is the end. So if we open this one, which is this circle, that circle here, it's 32. So come back here and make this circle as 32. Like that, and let's make it as a construction line, because it's not a complete circle. So we will make it as a construction line. This circle, we will make it as a construction line. Right. Now let's draw this circle, which is multi-circle diameter, with, to get the value of this one, it's 85, 58. So the circle is 58, and let's convert it to construction. Okay, another circle at the outside, which is 78. Okay, so another circle, but this circle is a visual circle, not a construction line. Okay, so we draw this circle now. Okay, we have 2 other circles at the top here. One of them is 12. The second one is 22. So let's draw 2 circles. One of them is 12. And the second one is 22. You can figure that from this sketch, the center line of this circle located above this one. So they are in a vertical position. So how to do that? By using the constraints. So from here, let's select a vertical position and make this point vertical over this point. So this point will move up and down. Now we can define the location of this one. So it's 57 from the center line. So let's come back and define the center line from here to here is 57. Now let's come back and draw those circles. We have here two circles. The first one is 80 millimeters diameter and the large one is 36. So let's come here on any place and add two circles, another two circles here. And let's make or try another option. Let's make a vertical line first and make this line as a construction line. And let's use the symmetric option. Okay. I'm trying to show you, you can make it by different ways, but I'm trying to use all constraints to show you how you can think to make your drawing. For example, let's select symmetric, and you would like to make the inner circle looks like the other inner circle around that line. The same for the outer circle, makes this circle looks like the outer circle around the that line. Okay, so when you change that one, you will be able to make it like that. And when you move it, they will be, as you can see, they are symmetric. Now, let's define the offset between them. It will be 90 millimeters, so it will be like that. And the offset of this one from the top, 104 millimeters from this point. So let's come back and measure the distance from here to there, and you can figure that you can make it vertical, horizontal, or aligned. But we don't need the aligned, we need it vertical. So let's select vertical to define the vertical position, 104 millimeters. Now, those circles, the center of those circles become fixed. You can figure that the color of this point become blue, not black. But the circle's dimensions is still flexible because we didn't define the value for the diameter of each circle. So let's come back to check the values. So the inside diameter is 18 and the outside diameter 36. So from here, let's define this as 18 and the outside diameter is 36. Now you can figure that because the constraints that we did from here to there, you can figure that this one become fixed. No ability to change it because you defined the dimension for that. Okay, let's go to the next step, which is making one of those shapes. We need to make one of those shapes and make a pattern for it. So here we have the diameter of this circle is 14 millimeters. So the circle diameter is 14 and the width of this slot is 60 millimeters. So let's come back to Invent. And from here, let's make a circle. So the center of this circle will be located on the intersect point between the vertical line and this circle here. So let's make a circle, define the inside diameter as 14 millimeters. Okay, and let's draw two lines from here to there and another one from here to there, for example, and make a trim for the extend. So let's trim this, and now we have those lines. So if you select those two lines and make them equal, so we select them and make them equal like that. So if you change one of them, they will give the same result. Or you can use a symmetric, the same way that we did here. Make symmetric, select that one, symmetric to that one around the center line. But equal will give you the same result. So now you have those lines like that, and you will need to define the spacing between them, which is 6 millimeters. So by using the dimension, you will make them 6 millimeters. And now we need to make one more thing, which is the arc at the bottom. So we will use this type of arc. So define the center, select the start point, select the end point. Now we need to make a trim for the circle at this area. So by trimming this, you will get this shape. Now we need to make a circular pattern for this circle around the center line. We have 6 instances. So if you select those instances like that and make a rectangular pattern, so
The next step, select the center line. So let's select this one. The default value will be 6 and click on OK. Now we have this pattern for this hole. Now let's go to the next step, which is making an arc here, tangent to another arc, tangent to this circle. And the radius of this one is 20 millimeters. So let's say a circle first. This circle was 20 millimeters, 20. So we can find the value and make this circle tangent to that one. That's the first step. Now we need to draw an arc. Okay, this arc tangent to this circle and the tangent to that circle. So let's come back here and select arc, defined by 3 points. So select any point and select another point here and make an arc like that. But this arc right now, it's not tangent to anything. So select tangent to and select that arc to make that one tangent to here and there. So we have now this arc tangent to this circle and tangent to the second circle. We define the inside diameter or the diameter of this arc here, and we need one more value for this arc radius. I think it's not included in the drawing. If you can see, the value of this arc. I think it's not included, so we can define it by hand. So from here, let's make it 100 millimeters. So we have this one or this arc like that. So here, let's make another arc on the other side, or we can make a trim to this one. So by that way, you will get a tangent one like that. And if you would like to make a mirror for those items around the vertical line here, you will get that one. Now let's make this point vertical. I think vertical will not give the same result here, because let's increase the value of that one or increase it. I think now we could make it vertical. So this point, if we make it vertical, so it is not vertical. So we can delete this constraint by selecting it like that and delete the vertical constraint. So we can change it a little bit like that and add a line from here to there. Okay, so this line, you can see it's maybe located like that. So you need to make this point vertical to that one. So by selecting vertical and select that one, you will make the line in a horizontal position. So here the value is, that's 40 diameter, not radius. So it's 20 millimeter radius, so it will be 40 as a diameter. Okay, if we try to make it vertical, okay, it will not be the same. So we can define the spacing between the center line here and there as 120 millimeter. Now the sketch is fixed. By that way, we create the 2D sketch for this sample. Okay, we start making some circles. We learn in this one how to make points vertical to another points, how to make a pattern, how to make a trim for lines, how to use the tangent and the symmetric options, how to add dimensions for the model. So let's finish this one, and let's keep that in our project folder. because I would like to share it with you. So let's move to the desktop, and we have a demo of today. So drawing 1. Sorry, let's make a day 1 folder as a day 1. So for day 1, drawing 1. And for the second sketch, we will save it here. Day 1. Okay. So we have 2 sketches here, and I will share that with you by email. And I would like to receive, as we discussed on the beginning, inshallah, I will need a list for the attendance from Alzheimer's Steel with emails, because inshallah in each session we will make a small quiz. At the end I will send you some sketches. You can create it and send it tomorrow morning inshallah before the session to study it and discuss if you have any issues during sketching. Okay, so let's go to the next one, and let's create those sketches on a drawing. So from here, let's create a new part. Okay, and create a new sketch. Select YZ XY plane, and let's add the first from here. Let's make a print screen for this, and here. Now let's start with this view. We have, if we make a rectangle with 40 millimeters height and width 36 plus 8 plus another 8. So let's make a rectangle. Okay. The height of this rectangle is 40 millimeters, and the width will be 36 plus 8 plus 8. So you can make an equation here. So if you don't like to get a calculator and calculate that 36 plus 8 plus 8, you can calculate it here and take the final value, and you can make an equation here. Automatically, Autodesk Inventor will calculate that. So you click OK, you will get the width here. Now we have a fillet at the end with 8 millimeters. So from here, we will select fillet and define the value as 8 millimeters. You can select the corner as we discussed, like that, or you can select the first line and second line after that. So you will get a fillet like that. So after that, let's make those slots. We have a slot length with 8 millimeters and the offset 24 from the bottom, and the offset from here is 8 millimeters. So the center of this slot at the center of the fillet. So if we select the slots, you can select slot center line to center line. This one will cover what we need. So from that's the first center line, and the second center line will be like that. After that, you will select a point on the slot. Now let's define the slot dimensions. So the width of this slot, the radius here is R3, which means the diameter or spacing is 6 millimeters. So if you can define it by radius, like 3, or you can define it by the spacing, or here like that, as 6 millimeters. They will give you the same result. And here the height is 8 millimeters, which is the slot length. From here, select that one and 8 millimeters. You have one slot. You can make a mirror around the center line, or you can draw the same slot. If you would like to make a mirror, just draw a line, a vertical line as the middle, convert it to construction line. After that, by selecting a mirror, you can make a mirror for this slot around that line, like that, or make another slot by making a slot from center to center. So you can define that by that way, and by using equal constraint, you can make this radius equal that one, make this length equal that length, so you will get the same result. So by using the different available constraints, you can get the same thing. That depends on your thinking, what you would like to say to do. So you can make it by different ways and get the same result. It's depends on how you think. Okay, now let's make the second view, another view. We have an L shape with some lines here, so let's make the L shape. So you can draw a line like that. After that, we can define the dimensions. As you can see, when you make a roughly sketch, this line become not a vertical line. So to convert it a vertical, just select the vertical and select this line to convert it vertical, and that one automatically will be, because it's perpendicular, it will be in a horizontal position. Now let's define the length and width. So it's 10 millimeters here, and for the length, if we take a look here, it's 88 plus 14. So the length here is 88 plus 14. And the height, the same height, which is 40. So the height here equals that value. So you can select this value directly. Okay, again, to show you how you can make a link between parameters. So here, if you make that one, automatically you can select, you can figure that hand is appear now. When you select this one, automatically the height here equals this dimension. In the end, each dimension in Autodesk Inventor takes a name. It has a name. So if we open the management and open the FX parameters, those are the model parameters. The dimension number D0 equals 40 millimeters. Dimension D1 equals 36 plus 8 plus 8. D2 equals 8. So all dimensions here, each dimension takes a name. So you can make a link or make a parameters between the dimensions. So in that case, we make a relation between that one and that one. So anytime if you, for example, if we change it to 60, automatically the height of this one will be changed to 60. We come back to 40 millimeters, that one will change to 40 millimeters. Okay, now let's draw the third view here. We have 55 millimeters width. Let's come back here. We have this value, and that width is 32. So let's make a line. So come back to sketch, and from a line, let's make a line here, another one there, and like that. As we discussed, we need to make this line aligned to that one. So by using the collinear order, we will make this line parallel or on the same level with that one. So they will be over each other. Or you can make it by using a vertical point. So you can make this point by using the vertical, make this point vertical to that one. So that means those points will be vertical. So here I would like to discuss different options give you the same result. You can use it to give you the same result. Now let's define the dimension as 52. I think 52, not 42. 52, yes. And the length of this one is 32. So this one is 32. And you can use equal to make those lines equal to each other. So this line value will equal to that one. Okay, and if you select one of them, you can figure that equal value appear here and horizontal constraint appear here. This line takes two constraints, which is horizontal and equal, and that one takes a vertical position and perpendicular to that line. Okay, now let's make this arc and that one, and let's make this slot first. Let's make this slot first. So when we come back here, and let's make a slot from start, end, and point located on the slot. Let's define this slot length. It's 40 for length and here the radius of the end is 6 millimeters. So here it's 60 millimeters radius, and the length is 44. I think 44. Yes, it's 44. Now, if you try to move this slot, it will be moved like that. But actually, it's located on the center of this one. So you will need to make a constraint, makes this point at the center here. As we did with the vertical, we will make it by using the horizontal. So let's select horizontal position and make this point with the same level of the horizontal point. So here you can figure that you make them horizontal by that way. Okay, and you can figure that this sketch at the top moved up. So if you would like to make it aligned or collinear, this line with that line, so that will be on the same level. Okay, now we have this slot at the center of the line. Let's add another constraint. So from the end to the line, it's 88. So from here, let's select this center point to here, it's 88. Okay, let's add this line, that arc, and that arc. We can use, in that case, we can use the option of offset, okay, but remove the loop selection. Okay, so from here, if you select offset and remove the loop selection, if we activate it again, you will select the whole chain of this slot. But we need to select those lines only. So continue to make a slot like that. So from here to define the outside diameter, it's 14. So let's define that one as 14 millimeters. And here, let's add an arc from here to there. Let's create an arc tangent to the end. So from here, let's make an arc tangent from here to there, another arc tangent from here to there. Okay, and to define this arc value, it's R12. So define this as 12 millimeters, and you can make this one equal to that one. Now let's add those holes. We have two holes here, and they are with offset 20 millimeters from here and 28 millimeters. So let's add two circles. We have two circles like that. By using equal, you can make them equal. And by using a vertical, you can make them vertical to each other. And now let's define the diameter of the circle, which is 12 millimeters. So from here, it's 12 millimeters. Now, if you select one of them and move it up and down, it will be moved. So you would like to make them symmetric to that line. You can do that by making it symmetric. So you can make that one equal that one around that X. So when you try to select, they will be symmetric to that line. Now let's define the other dimensions, which is 20 and 28. So from here, if we define the offset between the center and center, it's 28. And from here to there, it's 20. So you will get that shape. Now you can figure that you will need to define the space between this view and that view. Let's make it 30 millimeters, and space between that view and that view, millimeters, for example. And now you finish the sketch. Okay, now you have this sketch, and if you would like to make the dimensions invisible, just right click on the sketch like that and make the dimensions invisible. Now you have this sketch, which indicates that shape, or that those three views here on that one. Let's save it, and in our project, which is demo and day 1 and part 2. So now we make 3 samples. The first sample for that one, the second sample for that one, and the third sample for this view. Now we have another one. This one, inshallah, will be our quiz. So inshallah, I will share this PowerPoint with you. And inshallah, I will receive tomorrow morning from your side sketches for this one. I will need this view and that view. For the as a 2D sketch, you can make it on the drawing or on the part. So I will need both views for that item in as a part. Now we will make an open discussion if someone would like to discuss something during this session before finishing, inshallah. Any questions? Hello? Hello?
Hello, Jess. Wilson, anybody having questions?
Hello? Any questions? We could discuss it on the next 30 minutes, inshallah.
Yeah, in the chat box, there are some few questions asking, like,
Yes.
is an option for adding alternative unit, both US and SI unit together in the dimension?
Adding what?
In the chat box, can you see the chat box? They are asking some question like, is there any option is there for adding the dimensional unit? Like we can add multiple unit, like a millimeter and inch together.
Okay, we discussed that when we get a new item, okay, and create a sketch. As mentioned, if you have, for example, a rectangle like that, okay, you can define, if you would like to define this length, the default units now in millimeter, but you would like to write this value in inches, so you can make it 1 inch like that. So I think you can see that if we take a print screen here, so you can figure that we define this value as an inch. So it's 1 inch. Okay. So after adding it in that format, 1 inch, and click on yes, automatically it will be converted because this file is the measurement unit. It's in millimeter. So automatically it will appear to you in millimeter, which is 25.4. But if you double click on it, you will find it in inches as you defined. Again, if you write it in 0.2 foot, like that, and click enter, automatically it will be converted to millimeter because it's the default units in millimeter. But if you double click on it, you will find it in foot, like that. The same if you would like to make a chamfer. Here, let's make a chamfer with different distances. So we will make it 1 centimeter, and here 0.3 inches. Okay, you define it in centimeter, and here in inches. Okay, so 10 centimeter, 1 centimeter, and on the other side like that. So the value of 1 centimeter converted to 10 millimeters, and the 0.3 inches converted to 7.62 millimeters. Okay, but anytime if you click on it, you will find the original unit that you defined on the here. Defined it here. Okay. Any other questions? Okay.
How we can project the center line? Can we make it visible the X, Y center lines? Take it as a reference.
We discussed that here from project. From project, you can select project geometry, and from the left-hand side, you will find the origin folder. If you open it, you will find the original axis here, X, and you can figure if you take a look here, you will find the red line appear. Okay, so if we print it, it will appear like that, and Y line. So you can get those two lines will appear here. Those are for the axis. And if you print the Z1, it will appear as a point because it's perpendicular to this plane. So if we project the Z axis, it will appear as a point, as mentioned, because it's perpendicular to the plane. So those features we will discuss it in detail, inshallah, because most of them usually used after making a 3D model.
Okay.
Okay, not in 2D sketch. Okay, any other questions?
In the dimensions of inches, there is no symbol or fixed symbol or inches symbol.
Actually, I cannot hear you clearly. I have an echo during. Would you mind to speak from another microphone or something like that? If you have a part like that, dimension style here will not reflect on the drawing. The drawing is another thing. Okay, the drawing is another thing, not the drawing setting itself. You can control the mix between units, and inshallah during the next sessions we will discuss that how you can make a mix, make the dimension appear in two formats, or for example here, as we discussed here, the angle including a comma and the precision in two, and if we measure the length, for example, from here to there, something like that, that's the value. So from all of that we will discuss it inshallah when we come to the drawing and how we can deal with the drawing dimensions and annotations, layers, all of that. But as a quick review, from the default style you can change this comma to period, not a comma. Make trailing for the precision. Automatically, if you have a value after the comma, it will appear automatically with 0.2. And from here, if you have an alternative unit, you can add an alternative unit, like add inches, and make this one appear like that. So the original value will be like that, and the alternative value appear between brackets. You can remove the original or the precision equipment. You can make it in a fraction value, and you can make it 1/32. So all of that you can make it. So when you click save, you can figure that you can change the style of the dimension which appear in your drawing. But all of that, inshallah, as mentioned, we will discuss during the drawings, this PowerPoint file. And I will need tomorrow, inshallah, from your side, from all attendants, make a drawing for this part, for those two views, the elevation and the top view. You can create it on the drawing, on the part, no problem. I would like to know how you will make it and how you can deal with the constraints.